Welcome to my YouTube channel. My name is Andile and this is the first lesson for 2022. So what I decided to do is I'm deciding to do the entire grade 12 syllabus, but making sure the fact that I touch base things from grade 10 and grade 11 because of that are also tested in the final exam. So to make everything simple, I'm going to start with number patterns. I'm going to go through how the syllabus goes. So this is going to be like I'm like your personal tutor, something like that. But I'm going to make sure the fact that I touch base with everything. So this is the first video to the series. I don't know whether to call this the series or to this study thing that I'm making. But I just want to explain how the videos are going to go. Obviously, in each video, I'm going to state how the video is broken down. But in this video, we're going to be talking about number patterns. Number patterns, the three main topics that you need to know under number patterns is arithmetic, which is the linear pattern, is the quadratic sequence, which is also called the quadratic pattern. Then the last one is the geometric sequence, which is called what? Which is called the geometric pattern, right? Then there's another section under it, which is going to be, you see the fact that I was talking about sequence. Then there's another section under, which is you touch base when you get to metric, which is you are in metric, which is called series, right? So how I'm going to do is when I talk about arithmetic sequence, I'm going to automatically talk about the series, right? So I'm going to combine it. So that's one thing. Then we're going to jump into the questions. Same applies with the geometric. When I talk about the sequence, I'm going to automatically talk about the series. The only one that doesn't have the series, but its series is basically in linear or in the arithmetic, is the quadratic, right? So what I'm going to do is we're going to start first with the general concept of what's number pattern, that I'm going to go deep into each section. So how I'm going to do it is I'm going to have a playlist. So I'm going to break down the video into sections, meaning if you want to go straight to what? To maybe geometric, because you want to focus on that, you can go straight to that. And another thing that I wanted to say before I start with the video is that I'm going to first do the notes, meaning I'm going to just brush you off, make you understand the concept. Then after doing the notes, we're gonna go through the questions, and the questions that I'm going to use is from past papers. So you're killing one bird, two birds. Sorry, I don't know, I forgot the phrase, what it says. But you're going to be practicing, meaning practicing using past papers, and at the same time you're understanding the concept. And if there's nothing that I said during the notes, I'm going to state it out. If it's an important something that you need to know, I'm going to state it out in the examples or the questions that we do. So that's what I wanted to say as the intro. So now let's start with the basic concept of understanding what is number patterns. So number patterns, first we need to understand what is a sequence, right? You need to understand the concept so that it's easy for you to basically grasp the entire topic by understanding the components in it. I hope I'm making sense. So they say, what is a sequence? According to Google, a sequence is a collection of objects, which at the top in orange it states that objects can mean numbers, right? In which repetitions are allowed and order matters. So when they say repetition, meaning the fact that how that number on how that pattern occurs is that you adding a certain number, meaning let's say we have 5, 10, 15, 20. To get to the next number, you can see the fact that if you start with 5, to get to the next number, which is 10, you add by 5. And at 10, to get to 15, you add by 5. So the repetition there is what? Is 5. I hope I'm making sense. So in repetition, which is I highlighted in pink, I go down and state the fact that in arithmetic, right, the repetition is D, which is the common difference, meaning it's the value that you keep on adding, which is going to be your common difference. Then in geometric, the repetition is R, which is what? The common ratio. So you see the fact that when we're going to talk about ratios, when we're going to talk about geometric, is that in geometric, we multiply by the common ratio, which we can multiply. Let's say I have a sequence and it's 2, then my common ratio is 2, right? So I'm going to have that value, which is 2 multiplied by 2, which is going to be 4. Then I'm going to say 4 multiplied by 2, which is going to give me 8. Then 8 multiplied by 2 is going to give me what? It's going to give me 16, if I'm not mistaken. But that's how it goes, right? I hope you get the gist of the concept. Then in quadratic, the repetition, if you will notice when we get to it, is that it's the second difference, right? The repetition is not the first difference, but it's going to be the second difference. We have a common difference, meaning if we're adding the second difference, if we're going to add by 2, 2, 2, that's going to be our repetition. So that's the concept of what? A sequence, right? Hope that made sense. So now moving to the next concept, which is I said we're gonna just sum up together and make it one, which is what is a series, right? Is adding up terms in a sequence. Let me just make it make more sense by just giving you guys an example so that you can see a difference between a sequence and a series. So for example, we have 5, 10, 15, 20, right? We see the fact that there's a common difference here, which is what? Which is 5. When you add 5 into each term, you get the next one. So this is a what? This is a sequence, right? So how do we know the fact that something is a sequence and something is a series? So if you have terms, right, which is you see the fact that you have 5, 10, and 15, if they are divided or split within the list. So for example, if you're given like the first one, the one that's divided by semicolon, right, is going to be, that's going to be your sequence. Then the one that's divided by an addition sometimes can be a negative. If it's a negative or an addition or a subtraction, if the terms, right, are divided by that is called what? A series. So that's how you would see the fact that something is a sequence and something is a series. Then the terms in this case is going to be 5, 10, 15, and 20. Then the first term in both of them is going to be 5. The second term, which is T2, is going to be what? It's going to be 10. Then the third term, which is T3, is going to be what? It's going to be 15. And the fourth term, which is T4, is going to be what? It's going to be 20. So that's how you would know each is that. Let me just write it down so that you guys can see it visually. So as you can see the fact that you have T1, T2, T3, and T4. So that would be the position T1, which is the first position, T2, second position, T3, third position, and T4, the fourth position. And the values for that is going to be 5, 10, and 15, and 20. So that's the gist of the concept. So now let's talk about a new concept, which is sigma notation. So sigma notation, the notation for that is the one that is in bracket. It looks like that. That represents sum. Whatever you see that sign, it means sum of. Sigma means sum of. So it says sigma notation is used to indicate the sum of the terms given by tk, right? Starting from k is equals to j and ending at k is equals to n. So what it means is the fact that when it says k equals to j, meaning j can be any number. So it can start at 3, it can start at 4, it can start at 5, it can start at 1, it can even start at 0, if I'm not mistaken. But it's that j can be any number. Your summation of the terms can start anyway, right? Then the ending, which is n, is going to be what? The last term, right? Which is the last term that you need to add up the terms till that term. I hope I make sense. You're gonna get the idea more when I do the questions. Everything's gonna make sense. So just don't panic. Then another thing is the fact that tk, which is this one, right, is the what? Is the general formula. So please remember that when we do questions, just remember the fact that the tk, it's not always going to be k. They can use any any alphabet, but in our case tk, right, is going to be the what? The general formula. So just remember the fact that that is actually the general formula. But as I said, the fact that you're going to get the gist and how to understand the segment notation when we do more questions. So now let's start with the actual gist, which is the first topic under number patterns, which is going to be arithmetic sequence and series. So now let's start with the arithmetic sequence and series. So the first thing that we need to know is that arithmetic sequence and series is the same as linear pattern. You've done this in grade 10, so this is just a recap. They just decided to make the name fancy and call it arithmetic, but this is basically a linear pattern. So the first thing that you know about a linear pattern is that it has a common difference, and the difference is d. So you know the fact that the first point, it has a common difference, right? So it has a common difference and is represented by d, right? And how do you find that common difference? The formula is d is equals to what? Is 2 equals to tn minus tn n minus 1, right? Meaning the fact that to find the common difference, if we had, for example, if we had terms, it's going to be what? D is equals to what? To t2, then if n is 2, then n minus 1 is going to be n minus 1 is going to be 2 minus 1, which is going to be minus t1. So this is for reference to use this formula, right? Then the second important information about that is to know the general formula. So the general formula for a linear pattern is this. So the general formula, right, is Tn is equals to A plus n minus 1, right, multiplied by d, where A, right, is what? Is the first term, and d is what? As we wrote, is the common factor. Common difference, sorry. So with that said, is that if they say find the Tn, they normally say find Tn, or they would say find the general formula, the general equation. I forgot how do they phrase it in the question. You would use this formula first to complete this equation. You're going to need your A and you're going to need your D, and that will be your answer, right? Then under series, right, is that we need to find Sn. Sn is the sum of all terms. So we have two formulas for Sn, right, which is going to be what? Which is going to be n divided by 2 is going to be A plus L, right? Where A is what? Is the first term, and L is the what? Is the last term, right? Under arithmetic, we have two sum equations, right? We have another one, which is quite long, which is Sn, which is going to be n divided by 2, open bracket, 2a plus n minus 1 multiplied by d. As you know, the fact that here a is going to be what? The first term, right? And d is going to be your difference. So this 1, 2, 3 are going to be what? Your important formula. Actually, it's 4 of them. It's 1, 2, 3, 4 are going to be your what? Your important formulas that you're going to need to answer questions. And another thing, just an extra note, just to put there, is that an arithmetic sequence is what? Is actually a linear function. It's a straight line. If you had to plot this one, right, you're going to actually get what? You're going to actually get a straight line, or you're going to get a linear function. So that's all that I wanted to say. Extra things, if I need to spice it on, is that I'm going to say it through the questions. So now let's start with the questions for what? For arithmetic sequence and series. So this question is from 2021 and it's question number 4 and it's a question for linear pattern. As I said, linear is arithmetic, just a fancier way to say linear, which is arithmetic. So the first one says, consider a linear pattern 5, 7, and 9. Then what do we know? Because of its semicolon, we know the fact that this is not what? This is not a series. It's a what? It's a sequence because it has semicolon in between the terms, right? So the thing that I like doing before answering any question, whether it's geometric, whether it's linear, whether it's quadratic, is that I write down the general formula before answering anything, right? So with this one, before we actually look at the questions and we do everything, let's find the general formula, right? So we know what the general formula is. I'm not going to write the number, which is 4.1, because of as so far I see the fact that they haven't asked me that. So I'm going to say Tn is going to be equals to what? It's going to be equals to a plus open bracket n minus 1 multiplied by d, right? So what do I see? I need a to complete the general formula, and I need d. So what a is 5, so I can say Tn is equals to 5, and now I need d plus n minus 1, then I need d. To find d is what? We know the fact that d is equals to what? 2Tn, right, minus Tn minus 1. In our case, it's going to be d is equals to what? 2T2 minus T1, which is going to be d is equals to 7 minus 5, which is going to give me what? Which is going to give me 2. Right? So I know that my d is 2, so I'm going to substitute it here, which is going to be 2. So you can also do this, which is the most simplest one. You're going to say 7 minus 5, which is going to be 2. And when we say 9 minus 7, which is going to give you 2. To check again, just make sure the fact that you take the next 2 terms to check whether your common difference is actually correct, so that you don't miss marks for no reason. Right? So simplify this, you know the fact that Tn is going to be equals to what? To 5, right? Plus 2n minus 1. Therefore, Tn is equals to what? It's going to be equals to 4 plus 2n, right? Before doing anything, please check whether your Tn is correct or not. See, when I say check, please check, because of our Tn is not 4, but it's actually what? It's going to be 3, right? Because I forgot to distribute the 1 here. It's going to be 3 plus 2n. And when I substitute, I always substitute like the third term, right? So when I substitute the third term, I see the fact that I still get 9. You can try it. So this is going to be your what? Your Tn, right? So now let's answer the questions. So now let's answer the question. It says 4.1. It says determine T51, T51, right? It's going to be equals to, taking the general solution, right? So we know the fact that 51 is where is by n. So wherever we see n, we're going to substitute by what? By 51. So you're going to say 3 plus 2, open bracket, what? 51, right? And when you punch that into the calculator, you're going to get what you call this T51 as being equals to what? To 105, right? So now 4.2, it says calculate the sum of the first 51 terms. So we're going to use the what? We're going to use the sum formula. So I'm going to use the one with the first term and the last term. And the reason why is that I already know what's the last term. They said 51 terms, meaning the last term is going to be what? T51. And I already know that fact that T51 is equals to 105. That's why I'm using the Sn with the first term and the last term. So I'm going to say Sn is equals to n divided by 2, which is a plus L, right? And we know the fact that we're looking for the sum for the first 51 terms. So wherever I see n, I'm going to substitute by what? By 51, because it's the first 51 terms. So you're going to say S51 is equals to 51 divided by 2. Then here we know that our first term is 5, so you're going to say 5 plus what? Plus 105, right? Because T51 is equals to what? Is equals to 105. I hope I'm making sense. And when you punch that into the calculator, you're going to get your SN to be this value, which is 22,805. Then moving on to 4.3, right? It says write down the expression, the one that they gave you, which is sigma. Then the last term is 5,000, the one on top, that's the last term. Then it start at n is equals to 1. So it start at the first term. When we substitute in here, the first term as being n is equals to 1. Then they say show only the first 3 terms, right? And the last term, right? So how do you do that? We know the fact that this function I'm going to highlight now, this one is what is your general solution. So you know the fact that Tn, right, in this case is going to be equals to what? To 2n plus 3. What do we see? We see the fact that our Tn that we just solved and this one is exactly the same. So we already know the first 3 terms, which is going to be 5, 7, and 9. I hope I'm making sense, because of if this one, because we already solved Tn and it's exactly like this, I don't need to calculate it because of already they gave me that. So I know the fact that my first 3 terms is going to be what? It's going to be 5, right? 5. And they said I must write this in what? This expression with the first 3 terms. Since this is sigma, I can't put the semicolon, but I need to add them, right? So it's going to be 5 plus 7 plus 9. I hope I'm making sense, because of this sigma represents an addition. We adding terms. So I can't put a semicolon because I'm just basically saying the fact that that's a sequence, and that's not a sequence. It's a series. I hope I'm making sense. Then it's going to be plus. Then the last term is the one that I want, which is I need T what? T5000. So let me solve for that. So I'm going to say T, then I'm going to say 5,000, right? It's going to be equals to what? It's going to be equals to wherever I see n, I'm going to put 5,000. So it's going to be 5,000, right? Plus 3, which is I'm going to get what? Which is I'm going to get my T5000 as being this value, 10,003. So this last term here is going to be this value. I hope that made sense, right? So now let's move on to the last question for this 2021. It says hence or otherwise. Let me just go further down so that we have space. It says hence or otherwise calculate the sum, the sum from n equals to 1 till 5,000. They gave me that. Plus when n is equals to 1 till 4,099, then they gave me a different one. Show all working hours, right? So for me, the easiest way out to do this question, I'm gonna break it down. So I'm gonna show you. So we know the fact that we have the summation, right, of 5,000, which is this one, right? And we know it starts at n, then it's going to be 2n plus 3, and plus another summation, right, of 499, right, where n is equals to 1, then it's going to be negative 2 minus 1, right? That's what we have. So I'm going to focus on this one. Then I'm going to focus on the other one. So I'm going to first focus on this one. This one I'm going to write in orange so that it doesn't so you can see it properly, basically, right? So we know the fact that this one, when we break it down, what can I do? The summation, we can write it in terms of the formula. So is n is equals to what? To n divided by 2, right? Then I'm going to use the formula where I'm using the first term and the last term, which is going to be a plus l, right? So what do we need? to complete this, we need N, we need A, and we need L, right? So N is going to be what? Since it's starting, very important, since it's starting at N is equals to 1, then our N here is going to be equals to what? It's going to be equals to 5,000. Hope that made sense. Then our A is going to be what? Our A is going to be our first term here. So A is going to be equals to when we substitute 1 here. So it's going to be when N is equals to 1. So if we do that, if we say 2, then we substitute 1 plus 3, then our N is going to be equals to what? It's going to be equals to 5, right? Then our L here is when N, right, here in the function, when N is equals to what? To the last term, which is 5,000, the one that's on top, right? That's going to be our L. When N is equals to 5,000, we already calculated that, which is going to be 10,003. Hope that made sense. So now let's substitute it. So when we substitute it, let me just put some space here. When I substitute, it's going to be what it's going to be. When N is 5,000, which is going to be 5,000 divided by 2, then it's going to be A, which is going to be what? In our case, it's going to be 5. Then the last term, which is what? When N is equals to 5,000, which is going to be plus 10,003, right? Simplify that. When we simplify that, the value that you get is this one, pretty long number, which is this. 1, 2, 3, 4. So that's the first part, right? So I know the fact that whatever that's going to go here in the first portion is going to be this one. So now for the pink one, which is going to be this one, right? Let me reduce the pen. We know the fact that what we can change this into being what? Into being sigma, into being the sum formula, not sigma. So we're going to say Sn is equals to, same formula using the first term and the last term, which is going to be N divided by 2. Then you're going to say A plus L, right? So in our case, N here is going to be what? It's going to be 4,999, right? Then our A is going to be what? When N is equals to 1. From this one from here, right? Even here we took the one from here. So let's substitute. It's going to be equals to, you substitute onto this formula, right? So you're going to say it's going to be equals to negative 2 open bracket 1, right, minus 1, and that's going to give you what? That's going to give you negative 3, right? Then our L is when what? Is when N is equals to 4999, which is we took it from here, right? So we're going to substitute 4999. So it's going to be negative 2 open bracket 4999, right, minus 1, which when we substitute that, we're going to get what? We're going to get negative 9999, right? So let's substitute the two values, the three values into the function, into the formula. So it's going to be what? It's going to be 499, right, divided by N, open bracket, the first term is negative 3, minus 9999. So when we simplify that, you get negative 24, then 1, 2, 3, 4, then 6 nines. Right? Then now, to simplify this question, I'm going to take the orange one plus the what? Plus the pink one. So let's do that. So it's going to be Sn now. This question, when we simplify it, it's going to be 2, 5, 0, 2, 1, 2, 3, 4, right? Minus what? Minus 24. You see why I said negative? Because of if this is a positive and we have a negative, it's going to be negative. So you're going to say 999. Then it's going to be 999. And when we're done, you're going to get this value as being this. And this will be your final answer. I hope that made sense. So before we move on to the 2020 what you call this question, is that I want to correct something. I think you guys have seen it, is that here is not to the, not divided by n, but it's divided by 2. Right? Then you're going to get exactly the same answer, right? So I want to recap certain things here. Is that to find the a, right? Just remember the fact that you substitute the 1 in the bottom, as you see me doing in both of them. And to find y, to find l, right? So to find a, you substitute the 1 in the bottom, which is n is equals to the number, whatever number it is here, right? Then to find L, you substitute what? The 1 in at the top. It's going to differ with your L as time goes. I think I'm going to do questions where your n doesn't start at 1, but it starts at 3 or 2. Then it's quite different on how you find L. But in this case, when n is equals to 1, right, you're going to start your A is going to be when n is equals to 1. Then for your L is going to be n is equals to the one that's at top. This only works when n is equals to 1. But it's when n is equals to 2 or 3, your L is going to change. Your last term is going to change. I think for the sake, let me just do an example of that, so that you can see what I'm talking about. I'm just going to I'm going to take this one, the same question, but I'm going to change n being equals to another number, right? So let me do that. So let's say you're given the question like this, and they say the fact that solve this, right? So with this one, you know the fact that you need to use the sum formula, because of you can't like substitute from 3 till 5,000. You know, by the time the exam is done, you don't have time to complete the entire question, right? So what I'm going to do is I'm going to show you using the formula, which is the Sn, right? Which is Sn is equals to n divided by what? Divided by 2. Then it's going to be a plus l, right? Or you can use the other formula. It really doesn't matter. Very important. When I say n, I mean this n, right? This n and the last term, they share a same number. So first, we know the fact that in the formula, what do we need? We need n, we need a, and we need l to solve this question. I hope I'm making sense. So now I'm going to show you a way why we find what you call our n, and the n that you substitute by l the way that we do is that first our a, right? Our a, as I said, it always remains the same. Let me change my highlighter. Our a, the n for it always remains the same. Is the what? Is the n, when the n is equals to this number, is going to be the one that you use for a. So here you're going to substitute when n is equals to what? To 3. Because that's what's written here. I hope I'm making sense. Then you take this formula. This formula is your Tn. So wherever you see n here, you're going to substitute by 3. So let's do that. It's going to be 2, open bracket, 3, plus 3. So when you punch that into the calculator, you're going to get your answer as being 9. So here, our a is 9. So now let's say the fact that they changed, and I'm going to make it simple for a reason. Let's say they change here and it's not till 5,000, but it's till 10, right? Not 5,000. I'm making an example when the summation, right, is from 10. It ends at 10, but it starts at 3, right? So, and the same formula. How you would find this n value, this one here in the formula, right? So what it means is the fact that you would have terms. So you have T1, T2, right? T3, T4. I'm going to write till 10, T4. Let me just move the screen here. I just want to show you guys. T4, T5, T6, T7, T8, and T9, and T10. I hope I'm making sense, right? So what it means is the fact that your values are going to start where you're going to start here at T3. See the n here, the small n here is your T3. So this represents this number. So you're going to start here. Then it's going to end here. It's going to end here at when n is equals to 10. I hope that makes sense. So you need to know how many values are there. So now, since we're starting at 3 and we're ending at 10, we have 1, 2, 3, 4, 5, 6, 7, 8. So what do you see? We see the fact that in total we have how many? We have 8. So our n in the Sn, right? Our n, this n, is going to be equals to what? It's going to be equals to 8. So this n is going to be equals to 8 because we didn't start with T1 and T2. We started at T3. So we have how many terms? 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be what? This total minus 2. I hope I'm making sense. So using that knowledge, the fact that to find your n in your Sn, very important, to find your n in your Sn, it's basically what? It's going to be the one on top, which is going to be 10, minus the number before the one in the bottom. So the number before the one in the bottom, which is 3, is going to be 2. So it's going to be minus 2. Then 10 minus 2 is going to give me what? It's going to give me 8. With that knowledge, now I'm going to do this one. The one from the question that I just made as an example. Is that here, our n now is going to be what? It's going to be n here is going to be equals to what? The one on top, which is 5,000, minus the one at the bottom, the number before it. The number before 3 is what? Is 2. So it's going to be minus 2. The reason why it's not minus 3, if here we didn't say, if we didn't include 3, it was going to start at 4, meaning 3, you didn't start at 3, you technically started at 4. So, but we know the fact that the number, the third term is the one that's involved. We need to start there. The numbers that don't exist is the numbers before that, which is T1 and T2. That is why it's minus 2 terms and not minus 3 terms. I hope I'm making sense. So 5,000, right, minus 2 is going to give me what? 4,998. So it's 4,998. So that would be your n. So this n is the one that you're going to use to find your your last term, which is going to be n is equals to 4,998. So this was the one that you're going to substitute into this formula, which is going to be 2 open bracket 4,998 plus 3 is going to give you what? 2 open bracket 4,902 multiplied by 4,998, right? Close bracket, plus 3 is going to give you 999. So you're going to get 9999. Hope that makes sense. So it differs when you have n, and I think you see it why when n is equals to 1, it's the last term is going to be just the one on top, and when this one this number changes at the bottom, it actually is not this number at the top, it's not the same n terms. I hope this clarified it. And when you see a question like this, because this is how it would get tricky in the test, is that knowing what is the last term, because of it's determined by the starting term, which is this one is the what? Is the starting term. Remember, starting term, right? And this one is the last term. I hope everything made sense, and you guys are a little bit comfortable with this type of questions. And just remember that here, this was a mistake, right? It was not divided by n, but it was divided by 2 from the formula. So now let's move on to the 2020 question. So now moving to the 2020 question, it's just one question on arithmetic. It says 7x, y, and negative 11 is an arithmetic sequence. Determine the value of x and y. When you see this type of question and you have two unknowns in the sequence, and they tell you, because here they already specifiedly told us what type of sequence it is, it's arithmetic, and they say determine x and y, which is two values, just remember the fact that you need to use simultaneous equation. This is how you would use it. So first, let me just write down the sequence down, which is 7x, y, then negative 11. right? So we know the fact that we're looking for x and y. So here, what is the thing that we can use to find our x and y? What do we know? We know the fact that the difference in an arithmetic sequence is what they all equal, right? So I know the fact that if I subtract this 2, right, it's going to be equals to when I subtract this 2. The difference in between are equals to each other. So let me use that concept to basically solve my equation. So I'm finding what? The difference, right? I know to find the difference, I take the number before it, which is going to be x minus 7. So it's going to be x minus 7, because it's going to be what? T2 minus T1, right? And here it's going to be what? It's going to be T3 minus T2, which is going to be y minus, right? Y minus what? Y minus x, right? And the last one is going to be what? It's going to be T4 minus T3, which is going to be negative 11 minus y, right? What do we know? We know the fact that x minus 7 is equals to what? It's equals to y minus x. It's equals to what? Is equals to negative 11 minus y. Because of this 3 represents d. So this is equals to d, right? Which is the difference. This is d. And this is d. In arithmetic sequence, the common difference is the same. So we know the fact that x minus 7 is going to be equals to y minus x, which is going to be the same as being equals to what? Negative 11 minus what? Minus y. So what do we need? In simultaneous equation, we need two equations, right? We need the first equation, the second equation. From the knowledge, the fact that they all, they all equals to each other, we can create what? We can create two equations. So starting with the first one, I can say, let me just move it here, right? So I can say x minus 7 is equals to what? To y minus x, right? Simplify this, making one either x or y the subject of the formula. In my case, I'm going to make y the subject of the formula. So I'm going to take the x to the other side. So it's going to be x. When it goes to the other side, it's going to be positive. So it's going to be x plus x, which is going to give me 2x minus 7 is equals to y, right? So this will be my what? My first equation. So now let me create the second equation. I'm going to say y minus x is equals to negative 11 minus y. Hope that makes sense. So I'm going to say y minus x, which is this one, is equals to negative 11 minus x, which is this one, right? Because the d's are the same. So it really doesn't matter. So they are equals to each other. So in our case here, I'm going to make what? I'm going to make x the subject. So I'm going to take x to the other side, the y to the other side. When I take y to the other side, I'm going to be left with negative x is equals to negative 11. And this one is positive. So when it goes to the other side, it's going to be negative. So it's going to be negative 2y. Then since I want to make my x positive, I'm going to divide both sides by a negative, which this one changes into a positive. So it's going to be minus. Then everything that's negative is going to be changed into a positive. So it's going to be 11 plus 2y, right? So that's what we have right now. And this I'm going to call as being equation 2. Right? So now what I'm going to do is I'm going to substitute the first equation, right, into the second equation. So let me do that. So wherever I see the first one, wherever I see y, right, I'm going to substitute by the first equation. So let me do that. I'm going to take the second equation because that's the one that I'm substituting into. So I'm going to say x, right, is equals to 11 plus 2, open bracket, by the first equation, which is going to be 2x minus 7, right? So it's going to be x is equals to what? I'm going to distribute the 2 inside. So it's going to be 11 plus 4x. Then it's going to be what? Negative what? Negative 14. So it's going to be minus 14, right? Then simplify, take the one with the x to the one side and the one without the x to the other side. So I'm going to take what? I'm going to take the 4 to the other side. So I'm going to have x, right? X minus 4x is equals to what? To 11 minus 14. So 11 minus 14 is going to give me what? 3. So I'm going to have negative 3. So x minus 4 is going to be negative 3. X is equals to what? To negative 3. Then divide both sides by negative 3, which therefore it's going to give me x is equals to what? To 1. So I know that my x is going to be equals to 1. So I'm going to take this 1 and substitute it to the first equation. So let's do that. So it's going to be 2x, right? 2x minus 7 is equals to y. Substitute my x, so it's going to be 2. Then 1 minus 7 is equals to y. So punch that into the calculator. You're going to get your y as being negative 5. So y is going to be equals to negative 5. So your x is positive 1 and your y is going to be equals to negative 5. So I am done with the 2020 question. So now let's move to 2019. It says without using a calculator, determine the value of, then they give you. Remember the fact that they said without using a calculator, so we can't basically find the sequence then after finding the series. It's a series because it's an addition, but we can't find the series, then we can use the formula because of they specifically said without using a calculator. So what we need to do is we need to break down the series, both components, like separately. So we know the fact that we're gonna have, I'm just gonna rewrite it here. So it's going to be it ends at 10 and it starts at when y is equals to 3, right? Then our function or our general solution, not general solution, our general formula is y. It's 1 divided by y minus 2. Then it says minus a series, it ends at 10, right? But it starts at y is equals to what? To 3. Then our general formula is y minus 1. So let me just move it here. So what we do is, since they said very specifically without a calculator, what I'm going to do is I'm going to find the terms. I'm going to substitute from, this is not 3. The first one, it's from, let me just make sure. I think this question, yeah, they both start at 3. So yeah, so that's okay. So what I'm going to do is I'm going to substitute my y from 3 till 10. So let's do that. So you're going to have here, it's going to be equals to this first part, which is I'm going to do in orange so that it doesn't confuse you. It's going to be 1 divided by, where I see y, I'm going to start at 3. So it's going to be 3 minus 2. Then it's going to be plus 1 divided by 4 minus 2. Plus what? Plus 1 divided by 5 minus 2 plus 1 divided by what? 6 minus 2 plus 1 divided by 7 minus 2 plus 1 divided by 8 minus 2 plus 1 divided by 9 minus 2, right? Then the last one, which is plus 1 divided by, because it ends at 10, 10 minus 2, right? So that's all of them. So I'm going to simplify them. When I simplify them, I'm going to have what? I'm going to have the orange part as being 1 divided by 1 plus 1 divided by 2, which is the second term. Then 1 divided by 3. Then it goes on. Then 1 divided by 3, right? Then it's going to be, so this is all of them. It's going to be 1 divided by 1, 1 divided by 2 till 1 divided by 8 when you simplify the top part, right? Then you're just going to leave it the way it is, right? So now moving on to the pink side, which is going to be this side, we're going to basically expand this one, right? Exactly the way we did with the other one. So for the pink side, it's going to be equals to what? It's going to be 1, right? Divided by what? Divided by, we start at 3, so it's going to be 3 minus 1. Then you're going to say plus 1 divided by what? It's going to be, what you call this, 4 minus 1. Then you're going to say plus, it's going to be what? it's going to be 5 minus 1, then it's going to be plus 1 over 6 minus 1, then plus 1 divided by what? By 7 minus 1, right? Plus 1 divided by what? By 8 minus 1, right? Plus what? Plus 1 divided by what? Divided by 9 minus 1. And the last one is going to be plus 1 divided by 10 minus 1, right? So let's simplify that. It's going to give me what? It's going to give me 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 plus 1 over 6 plus 1 over 7 plus 1 over 8. Let me just go up. 1 over 8 plus the last one is going to be 1 over 9. So that's what we're going to get, right? So taking those two, I'm going to basically substitute the orange one here, and I'm going to substitute the, the pink one next to this one. It's going to replace the one within that has a negative in front. So let me do that. So this is how it looks when you basically write it down when it expands. But what do we see? We see the fact that everything in pink is going to be negative, right? So if we write everything in pink, that's going to be negative. We're going to have. So now everything in pink is the one that has negative values. But what do we see? We see the fact that we have a half, a positive a half, and a negative a half. And we're going to cancel the one that has opposite sides, right? We have a positive and a half and a negative a half. So this one, they're going to give you 0. The 1 over 3 is going to give you 0 because it has the negative 1. The 1 over 4 also has the negative 1. Then the 1 over 5, see? They're going to cancel. The one that has the positive and the negative are going to cancel each other because they're going to give you zeros. So this is how it is, like this. So now what we left with 1 over 1 is still 1. So it's going to be 1 minus the side we left with 1 over 9. So that's what we left with, which is going to give you what? It's going to give you 8 over what? Over 9. Then you are done with this question. So now let's do 3.2. It says a steel pavilion at a sports ground comprised of series of 12 steps. So in total, we know the fact that we have how many steps? We have 12 steps, right? Of which the first 3 are shown in the diagram below. So they only give us 3 steps shown visually, but in total there are how many? 12 steps. They say each step is 5 meters wide. So we know the fact that each step is going to be what? 5 meters wide. Then they say each step has a rise of what? Of 1 over 3 meters. So you know the fact that each step has 1 over 3. A rise of 1 over 3, right? And a tread of 2 over 3 meters, which is this one. So this would be the tread, right? As shown in the diagram, as they show this, they say the open side shaded of the shield. So this is the open side that they mean. This one, the one that I'm highlighting in orange. That is the open side, right? On each of the pavilion must be covered with metal sheeting. Then they want us to calculate the area in the in meters squared of the metal sheeting needed to cover both sides. So remember the fact that when we calculate the area, we're not doing for 3 steps, but we're gonna have to take in consideration how many? 12 steps, right? So now let's answer the question. So since now we need to find the area of the side, I'm gonna break down, I'm going to do it in pink. I'm going to break down each component right here, right? So the first step is going to be just the small part, right? So that is going to be the first step. To find the area, remember we need the what? We need the length times breadth, right? And the second step is going to be this component, right? If you can see, is the fact that this component, the second step is what? Is double the first one, right? Then the third one is going to be this one, the area of this one. If you look at it, it has what? 3 times of the first one. So knowing that, we need to find the area. So this will be the first one, this is going to be the second one, and this is going to be the third one, right? So that you can see it visually, is that to find the area, we need to find the areas of the small components of each steps till the 12th one, right? So for the area one, so the first area, which is for the first step, is going to be equals to what? It's going to be equals to length times breadth, right? So this is our length, right? And this is going to be our breadth. So what is our length? Our length is 1/3 because they already gave us. And remember the fact that the length is the same throughout. Each step has the same length, right? But the length is going to differ with each step because of, you see the fact that the second one has double the first one, and the third one has 3 times the length of the first one. I hope that makes sense. And the breadth is going to be what? This one, which is going to be 2/3 meters. So to do the first one, is going to be what? It's going to be area is equals to length times breadth, which is going to be equals to what? To 1/3 multiplied by what? 2/3. Then when we multiply this together, it's going to be 1 multiplied by 2, which is going to give you what? It's going to give you 2. Then 3 multiplied by 3 is going to give you 9. So this is going to be what? This is going to be the area of the first step. Then the area of the second step, so that you guys can see a pattern, right? It's going to be the second area. Then what you're going to see is the fact that the length of what you call this, the length, right, which is this one. I think let me just do it in another color. Let me just do it in black. The length of the second step is this one, right? If you see the fact that it's 2 times what is 2 times of the first one, so the length is equals to what? 2 times multiplied by 1/3, right? So it's just going to give you what? 2/3, right? And the breadth for that one is going to be what? It's going to be the same with the breadth of this one, which is going to be 2/3. So here, the area of the second triangle, right, is going to be what? It's going to be length times breadth, which is going to be equals to what? It's going to be equals to the length, remember, is 2/3. So it's going to be 2/3 multiplied by 2/3. So 2/3, which is going to be equals to what? 2 multiplied by 2 is going to give you 4, right? And 3 multiplied by 3 is going to give you 9. So the area for the second one is going to be 4/9. Then the area for the third one, right, which is, I'm going to do it in another color. Let me do it in green, right? It's going to be, the length is going to be this one, right? The length, if you see the fact that it's 3 times of the first one, so the length for the triangle is going to be equals to what? To 3 multiplied by 1/3. Then 3 multiplied by 1/3 is going to give you 1, right? Then the breadth is going to be the same thing as all of them, which is going to be 2/3 meters. So here, let me go back to pink. So here, length times breadth is equals to what? It's going to be 1, because our length is 1 from the calculation, right? Multiplied by what? 2/3. Then 1 multiplied by 2/3, what you're going to get? You're going to get what? 2/3, right? So let's write this in terms of what? A series, right? Remember the fact that we're adding up the areas, so we can't write it in semicolons, but we need to write it in addition because of we need the total area. I hope I'm making sense. So here the series is what? Is 2/9. Remember, series and sequencing, the difference is addition, right? Plus what? Plus 4/9. Then the third one is what? Is 2/3 plus ... till, remember, the 12th step. But before I'm finding the 12th step, I'm going to check whether there is a pattern here, right? So I'm going to check the difference between the two. So to check the difference, it's going to be this one minus this one. So if I say 4/9 minus 2/9, what I'm going to get? I'm going to get here, I'm going to get 2/9. Then here, which is going to be the third one, right, minus the second one. If I say 2/3 minus 4/9, I'm going to get what? I'm going to get 2 over 9. What do I see? I see the fact that I have a common what? I have a common I see the fact that I have a what? I have a common difference, meaning this is what? An arithmetic, which is a linear pattern, right? So knowing that, I can actually find the what? The area, the total area, using the SN, right? The SN, we know the fact that till the what? The 12th term, right? So we know the fact that the 12th term is because of in total there are 12 steps. So we know the fact that our SN, right, is going to be equals to, I'm going to use the one without the last term, the other one, the long one, the formula which is the long one, which is n divided by 2 divided by 2a plus n minus 1 then d, right? So here our n is equals to what? Is equals to 12 because of we have in total 12 steps, right? Then our a is going to be equals to what? The first term, which is going to be this one, right? Which is 2 over 9. Then our d, let me just go up. Then our d, right, is going to be equals to what? It's going to be equals to this, which is 2 over 9. Because we already found it. Checking whether it's a geometric or an arithmetic, right? Then knowing that, we can substitute into the formula. So let me just write it down. Let me just write it in the bottom because I need to say SN12. So now when we substitute into the formula, it's going to be S12, right? Is equals to what? It's going to be 12 divided by 2, open bracket, is going to be 2. Then it's going to be 2 over 9, right? Plus n is 12 minus 1. Then our d is what? Is 2 over 9, right? That when we punch that into the calculator, you're going to get, so when you punch that into the calculator, this is the value that you're going to get. You're going to get 52 divided by 3 meters squared. But remember the fact that this one is for only one side. We need two sides. The sheeting needs to be in both sides. So to find for both sides, right? For both sides, the area, right? For both sides, not sides, both, for both sides, right? It's going to be equals to this area multiplied by 2. So it's going to be this area multiplied by 2. So it's 52 divided by 3, which is going to give you what? Which is going to give you 104 divided by 3, which is equals to, in decimals, 34,67 meters squared. I hope it made sense why I multiplied by 2. Remember the fact that the stairs has two parts. It's, if you had to visualize the stairs, it has one side and it has another side. And what we calculated here was only one side, so we needed to calculate both sides because of the metal sheeting needs to cover both sides of the stairs. And they did say the fact that metal sheets needs to cover both sides. So this will be the end of this question for 2019. Then this question is from 2018. It's just a simple question. It says, given that the arithmetic sequence is 35, 28, and 21, calculate the term of the sequence that would have a value of negative 140. So what do they want? They want the n, right? We're going to look for n. So basically we're looking for which position is negative 140 in, is it in, right? So with that said, let's do the question. So I'm going to write it down here. We're going to have 35, right? 28. Then the last one is 21, right? So we need to find the difference here. So the difference, I'm going to use this one, this method, is going to be the second one minus the first one. So it's 28 minus 35, which is going to give me negative 7. Then to check, even if they told us the fact that it's arithmetic, to check whether it's truly 7 is, I'm going to take the third one, right, minus the second one. So let me do that. It's going to be 21 minus 28, which is going to give me negative 7. So now we know the fact that what? Now we know the fact that our difference, D, is equals to negative 7, right? So now what I'm going to use is I'm going to use the general formula to solve this. So we know the fact that the formula is Tn is equals to A, right, plus n minus 1 multiplied by d. So what are we given and what do we want? We are given the actual value, which is the actual value is the Tn. So we are given Tn as being what? Negative 140, right? And we are given A, which is 35, which is the first term, right? Then D, we just calculated it, which is what? Which is negative 7. And what are we looking for? We're looking for N, which is the position of what you call is negative 140. So now let's substitute everything that we're given. So when I substitute everything, let me just do it here in the bottom. When I substitute everything, let me do it in another color. So it's going to be 140 negative 140 is equals to 35 plus n is the one that we want minus 1, then multiply by negative 7. So let's solve this. Take this 35 to the other side. So it's going to be negative 140 minus 35 is equals to what? To n, right, minus 1 multiplied by negative 7. So if you say negative 140 minus 35, you're going to get what? Negative 175, which is equals to what? To n minus 1 minus 7. Divide both sides by negative 7, which you're going to get 25. So you're going to get 25 is equals to n minus 1. Then take the negative 1 to the other side. So it's going to be 25 plus 1 is equals to n, making your n equals to 26. So the position where negative 140 is, it's at T26. So T26 is equals to negative 140. So I hope you understood on how to solve that question. So now moving to 2017, it says the first three terms of an arithmetic sequence are 2k minus 7, then k plus 8, then, and the third term is 2k negative 1, right? Then they say calculate the value of the 15th term of the sequence. So they want T15. That's what we want. So to get T15, first we need to figure out the general solution. So to do that, we need to solve for k to find T15. So let's solve for k. Then after solving for k, we can find what you call this. After solving for k, we can find what? T15. So let's do that. So I'm gonna write it down here. So it's gonna be 2k minus 7. Then it's going to be k plus 8, right? Then the third one is 2k minus 1, right? No bracket. Then let me just move it here like this. Move it to the side like this, right? So the first thing that we need to do is what? We need to solve for k. So we can the only thing that we can use is the fact that since it's arithmetic, we know the fact that it has the same difference, right? So here is going to be what? It's going to be the second one minus the first one. So it's going to be k plus 8, right? Minus 2k minus 7. So let's solve this. Let's simplify it. It's going to be the same as saying what? As saying k plus 8, right, minus 2k minus plus 7, not minus 7, which is when you solve that, you're going to get negative k, right, plus 15, right? So that's what you're going to get. So here we're going to say the third one minus the second one, which is the same as saying 2k, right, 2k minus 1, right, minus open bracket k plus 8, right? So let's solve this. It's going to be 2k minus 1, right, minus k, right, minus 8, which is when you solve that, you're going to get what? You're going to get k minus 9. So that's what you're going to get. You're going to get k minus 9. So to solve for k, what do we know? We know the fact that these two are going to be equals to each other because of is an arithmetic. They have a common difference. So we can say negative k plus 15 is equals to k minus 9. Take the k's to one side, so I'm going to take this k to this side, so you're going to have 15, then I'm going to take the 9 to this side, plus 9 is equals to what? Is equals to k plus k, which is this side is going to give me 2k, and this side is going to give me what? Is going to give me 24, right? So therefore, divide both sides by 2, you're going to have your k as being equals to what? To being equals to 12. So that's what your k is going to be equals to. So now I'm going to write this sequence when I substitute 12. So the first one is going to be what? It's going to be 2 multiplied by 12 minus 7. Then the second term is going to be what? It's going to be 12 plus 8. And the third one is going to be what? It's going to be 2k, right? It's going to be 212, right? Minus 1. So you're going to have 2 multiplied by 12 minus 7. The first term is going to be 17. Then the second one is going to be 12 plus 8, which is going to give you 20. And the third term is going to be 2 multiplied by 12 minus 1, which is going to give you 23. Right? So now let's find the difference, because now we're going to be looking for T15. So we know the fact that to find T15, let's find the difference first. It's going to be like this. It's basically the second one minus the first one. So if you say 20 minus 17, it's going to give you 3. To recheck, you're going to say the third one minus the second one, which is going to be 23 minus 20, which is going to give you 3. So we know the fact that it has a common difference of 3. So that one you show with, right? So now, taking this, we're going to be looking for T15. So we're going to take the general formula, which is Tn is equals to A, open bracket, no, plus, and open bracket, n minus 1, then multiplied by d. So we're looking for T15, so we're going to say T15 is equals to, our A is what? Is our first term. In our case is 17, so it's going to be what? It's going to be 17 plus our n is 15, so it's going to be 15 minus 1, then our difference is 3. Then punch that into the calculator when you say 17 plus open bracket 15 minus 1, then open another bracket is 3, then close the bracket. You're going to get the fact that T15 is equals to what? To 59. And that would be your what? Your T15. So now moving to the second portion of the question, it says calculate the sum of the first even terms of the sequence. So we know the fact that they want the sum, right? So you're going to use Sn, but they want of the first very important even terms of the sequence. So with that said, let's write down the sequence, right? We already have it there, which was 17, right? Then it was 20, then the third term was 23. We're looking for even terms. So the easiest way out to do this is that write your sequence in a way, the fact that you can like have what? You can have 3 even terms. Take out those even terms, find the difference within the even terms, then calculate Sn for 30 of them. I hope I'm making sense, but I'm just going to show you, right? So we see the fact that the first even term here is what? Is 20. So we need 3 more, right? So after 23, if you add 23 by 3, right, because of the difference is 3, you're going to have 26. So we see the fact that our next even term is 26, right? Then you're going to say add another 3, so you're going to say 26 plus 3, you're going to have 29. But 29 is not an even term. But if we take 29 and add it by 3, you're going to have what? 32. So you're going to have 32. So the next even term is 32. So I'm going to take down the even terms, which is we have 20, we have 26, and we have 32, right? We needed to do it till what? Till T30. Because of we need the sum of 30 even terms, right? So what we need to do is we're going to have to find Sn. But before we find Sn, let's check whether this is an arithmetic. So we're going to find the difference, right? here within the even terms. So if I say 26 minus the second term minus the first term, 26 minus 20 is going to give me what? 6, right? Then if I say 32 minus 26, I'm going to get 6. So now we know for even terms our difference is equals to 6, right? So with that said, now let's find Sn. So I'm going to find Sn using the formula, the long one, right? So I'm going to say Sn is equals to what? 2n divided by 2, then open bracket 2a, right? Plus n minus 1 multiplied by d, then close the bracket. We know the fact that our n is equals to 30. Here it's going to be 30 because of our first even term, so it's going to be n is going to be equals to 30. Then a is going to be our first term in the even terms, not the original, because we're looking for even terms, right? So a is going to be equals to what? It's going to be equals to 20. Then our d is going to change. It's going to be from the one from the even terms, which is going to be equals to 6, right? So now let's substitute. It's going to be, let me just do this. It's going to be Sn is 12, S30, sorry. It's going to be S30 is equals to 30 divided by 2, open bracket 2 multiplied by a, which is 20, right? Then it's going to be plus our n is going to be 30, so it's going to be 30 minus 1, and our difference is 6. Then close the bracket. Then when you punch that into a calculator, you're going to get that Sn is equals to 3,210. So that's going to be your Sn for the first 30 even terms. I hope that made sense. So, and this is the end of 2017. So now moving to 2016, it says given the finite arithmetic sequence 5, 1, -3, then -83 and -87, write down the fourth term of the sequence. Then it says, so right here, right, we can find the difference, then add the difference by the third term, right? So let's do that. So we know to find the difference is the what? Is the second one minus the first one. So it's going to be 1 minus 5, which is going to give me -4. But to check whether it's truly -4, I'm going to take the third one minus the first one. So it's going to be -1 minus 1 is going to give me -4. So we know the fact that our difference is -4. So to find the T4, right, the fourth term is going to be equals to what? It's going to be equals to -3 plus -4, which is you're going to get -3 plus -4. It's going to give you -7. So it's going to be -7, right? Then 2.2, it says calculate the number of terms in the sequence. The reason why is that they gave us the last term as being 87. So now we need to calculate the number of terms in the sequence. So I'm going to use Tn. So it's going to be Tn is equals to what? Is equals to a plus open bracket n minus 1, then multiply by d. So now what we given Tn, we need to look for n. So we have Tn as being 87 because that's the last number, like the last value, right? Then a is the first value, which is 5, plus n, which is the one that we're looking for, then multiply by our d, which is -4. Take the 5 to the other side, so it's going to be 87 minus 5, which is going to give me 90. -92 is equals to what? 2n minus 1 minus 4, right? So divide both sides by -4, which is you're going to get 23. So it's going to be 23 is equals to n minus 1. Take the 1 to the other side, so it's going to be 23 plus 1, which is going to be n is going to be equals to 24. So our n in total here, there are how many terms? There are 24 terms, right? So T24 is equals to what? Is equals to -87. So that's what it means. Then moving on to the the equation, it says calculate the sum of all negative values. So to calculate the sum of all negative values, I'm going to write the sequence down so that you can see it visually. So it's going to be for 2.3, right? We have 5, right? We have 1, and we have -3, right? Then we go down till the last term. I'm just going to write the last term, which is -87, right? So where does it start being the negative term? It starts from being -3, because we know that the fourth term is -7. So from -3, all terms become what? Become negative, right? So to find the Sn for that is that we're gonna minus the total. So we know the fact that the formula for Sn is gonna be Sn, right? It's going to be equals to what? It's going to be equals to n divided by 2, open bracket 2a, plus n minus 1, right? Then multiplied by d, right? So that's that. But our n here, since we know the fact that the number of total terms is 24, our n can't be 24 because of we have subtracted 2 of them. So our n is going to be 24 minus the 2 positive terms, which is 5 and 1. So it's going to be -2 because they are 2 positive terms. So our n is going to be equals to what? 222. Then our a is the first term is not going to be 5, it's going to be this -3 because that's where we're starting. So a is going to be equals to -3. Then our d is going to be equals to what? It's going to be equals to -4. So now let's substitute. So when we substitute, it's going to be what? It's going to be S22 is equals to what? It's going to be 22 divided by 2, open bracket, 2 multiplied by a, which is -3, plus n is 22 minus 1. Then it's going to be multiplied by what? By -4. Right? Then when you punch that into the calculator, you're going to get that your Sn is equals to -990. Right? So that's going to be your Sn. So now going to the last question for 2016, it says consider a sequence 5, 1, the same one that they just gave us, 5, 1, -3, then till now our last term is -4,187. That's going to be our last term. Then they say determine the number of terms in the sequence that will be exactly divisible by 5. What does it mean to be divisible by 5? It means the fact that when we divide by 5, we get a whole number. We do not get a fraction. We do not get decimals. So we need to take out, to make it simple, we need to take out 3 terms right here that are divisible by 5. Then from the last one, we need to check which one. From the last time, we need to check which one is going to be divisible by 5, right? So to do that, let's find the first 3 terms so that we can create a sequence and find the difference, right? So we see the fact that for the first term is 5. If we say 5 divided by 5, you're going to get 1. So this first value is divisible by 5, right? So you're going to have 5, right? So let me write the entire sequence so that, yeah, 1, then -3, right? So we know the fact that the difference here is what? Is -4. So if I say -3 plus -4, I'm going to get -7, right? So I see the fact that 5 is divisible by 5, right? Then 1 is not. You're going to get a fraction. -3 is not. -7 is not. But if I say -7, then I add it by -4, I'm going to get -11, which is -11 is not. Then if I say -11, right, plus -4, I'm going to get -15. So I see the fact that -15 is divisible by 5, right? Then if I add -4 to -15, I'm gonna get what? I'm gonna get -19. Keep on adding, I'm gonna get -23, right? Then I'm going to get negative 27. Let me just go this side. Then I'm going to get negative 31. Then I'm going to get negative 35. Right? So I see the fact that I have negative 35. So this is my 3 terms. So it's going to be 5. It's going to be negative 15. And it's going to be negative 35. Right? That's what we have so far. So since now we have 3 terms that are divisible by 5, now we need to look for the last term that is going to be divisible by 5. So we see here that our last term is what? Is negative 4,187. But if we take that negative 4,187 and divide it by 5, we see the fact that we get a decimal, right? And we don't need the one that has a decimal. So we need to go forward. So we need to find values that are before it, like a value that's before it that is divisible by 5. So to do that, right, so I'm just going to do it here in pink. We have negative 4,000, right, 187. So since this is the last time, we need to go this direction to find numbers that are before it that are going to be divisible by 5. So remember to go in this direction. We added by negative 4, right? So meaning to go in this direction, we need to what? Subtract by negative 4. I hope that makes sense. So now to get the value before that is going to be negative 4,187 minus negative 4, right? Which is the value before that is going to be what? So the value before that is going to be negative 4,183. This is still not divisible by 5, so we need to find the value before it. Remember, we subtract by negative 4. So if we say that one minus negative 4, you're going to get what? You're going to get negative 4,179. Still not divisible by 5. Subtract by negative 4 again. So it's going to be minus 4, which is going to be what? It's going to be negative 4,175. If you take this and divide it by 5, you can see the fact that this one, right, is divisible by 5. So if this one is divisible by 5, so in this sequence, our last term, the ones that are divisible by 5, this value that I just highlighted is going to be the last value, right? So it's going to be negative 1,075, 4,175. So this is the sequence where the sequence is exactly divisible by 5. But remember, they say determine the number of terms. So they want n, basically, because we already have the Tn. So we're looking for n. We need to know how many terms are there in total that are divisible by 5 within the sequence, right? So let me just erase this. So now taking the new sequence, which is the one in orange. So let's move and come here, right? So now we're going to have to find the difference between the sequences so we can know D. So we know the fact that it's going to be negative 15. So it's going to be the second term minus the first one. It's minus 15 minus 5, which is going to be negative 20, right? Then to check whether it's truly negative 20, we're going to take the third one minus the second one. So it's going to be minus 35 minus 15, which is going to be what? Negative 20. Right? So that's what we have. So now taking the general formula is going to be Tn is equals to what? Is equals to A plus n minus 1, right? Multiplied by D. Remember the fact that we're looking for n because we want in total the number of terms. So our Tn is going to be the last term, the last value in the term. So it's going to be negative 4,000, right? 175 is equals to our A in this case is this one, right? So it's going to be 5 plus our n is what? Is going to be the one that we're looking for. So it's going to be n minus 1. Then our d is going to be negative 20. Then let's solve this. We're going to take the 5 to the other side. So when we take the 5 to the other side, we're going to say negative 4,175, right? Minus 5 is going to give me what? Negative 4,180 is equals to what? To n minus 1 multiplied by negative 20. Divide both sides by negative 20. You're going to get 209. So you're going to have 209 is equals to n minus 1. Take the 1 to the other side. So it's going to be 210 is equals to your n. So if our n is 210, therefore there are 210 terms that are divisible by 5 in the sequence. If we're going to end at 4,000, if we're going to end at negative 4,187. So I hope that made sense. So now moving to 2015, it says consider the series. Then they give you Sn is equals to what? To negative 3 plus 5 plus 13 plus 21 plus up to n terms, right? Then they say determine the general terms of the series in the form of tk is equals to bk plus c. What does that mean is that we're looking for Tn. The general terms is Tn, but now they just wrote it in terms of K because of already we used the N in the Sn. I hope that made sense. So you're looking for Tn, right? So for the first one, 3.1, we're looking for Tn. So we're going to say T, we're not going to say N, we're going to say K, right, is equals to A plus, so wherever you see K, wherever you see in the, remember the fact that the normal n is Tn is equals to A plus n minus 1, right? Multiplied by D. We're no longer going to write n, we're going to write K. So it's going to be K minus 1, right? Multiplied by D. The reason why, as I said, is that they already use n in the Sn, so they can't use it here in the general solution. I hope I'm making sense. So remember the fact that you need your A and you need your D, so they can be in this form. So now let's find what? Let's find D, because we already have our A. So our D is going to be what? The second term minus the first term. So it's going to be 5 minus 3, which is you're going to get as being 8. Then just to check that it's truly 8, you're going to have the third one minus the second one. So it's going to be 13 minus 5, which is going to be 8. So we know the fact that it's truly 8, right? So when we know the fact that it's truly 8, we're going to substitute. So tk, right, is going to be equals to what? It's going to be equals to A is the first term, which is going to be negative 3. So it's going to be negative 3 plus open bracket k minus 1 multiplied by 8. Distribute the 8, so you're going to have tk is equals to negative 3 plus 8k, right, minus 8. Then you're going to say negative 3 minus 8, which is going to get you negative 11. So tk, right, tk is going to be equals to 8k minus 11. Just to check the fact that your general solution is really proper, just substitute the third term, just substitute t3, right? So you're gonna say substitute t3, this I'm checking, so it's gonna be t3, and for t3 you need to get 13. If you get 13, then your general solution is correct, right? So it's gonna be your not general solution, your general form is correct. So it's going to be t3 is equals to 8 multiplied by 3 minus 11. So if you say 8 multiplied by 3 minus 11, you're going to get 13, so which is the correct one. So this was for checking purposes. So we know the fact that 3.1 is going to be equals to this. Then 3.2, it says write Sn in terms of sigma notation. Sigma notation, they mean that write it like this, right? So Sn, write it in this form. So let's do that. So Sn in terms of sigma notation, is going to be equals to, right? It's going to be the sigma. Then on top here is the last term. But you know the fact that the last term here is n because it says 2n terms. So we know the fact that here is going to be n. Then here, where does it start? It starts at what you call this, at k, because of our tk, right, is in terms of k. So we know the fact that k when is equals to 1, because when you substitute 1 here, you're going to get -3. That's why it starts at 1. Then here, the formula that goes here is the one that you just solved, this one. So here is going to be 8k minus 11, right? So here is your general formula. Then here's the number where it starts, so they can give you the first term, right? So this is going to be your answer for 3.2. Then 3.3, let me write it here. 3.3, they say show that Sn is equals to this, right? So we know the fact that we're gonna use the Sn formula. So you're gonna write the formula. So it's gonna be Sn is equals to what? 2n divided by 2a, right, plus n minus 1, right, multiplied by d. So because of they didn't give us the last term in how many terms, therefore our n is just going to be n. Then we're going to substitute other values. So we know the fact that we need to substitute a and d. So Sn, we're going to leave it like that. Then our n here is going to be n divided by 2 because we don't have any n value. Open bracket, our a is what? Is -3. So you're going to say 2 multiplied by -3 plus n minus 1. We leave it the way it is. Then our d is 8. So you're going to say 8, right? So multiply by 8, then close the bracket, right? So 2 multiplied by -3 is going to give you what? It's going to give you -6. So you're going to say Sn is equals to n divided by 2. Then here's going to be what? It's going to be -6, right? Distribute the 8. So you're going to have plus 8n, right, plus 8n minus 8, right? So you're gonna have -6 minus 8, right, which is gonna give you what? It's gonna give you -14. So you're gonna have Sn is equals to n divided by 2. Then here's gonna be -14 plus 8n, right? So distribute the n divided by 2 here. So you're going to have Sn is equals to n divided by 2 multiplied by -14 is going to give you what? It's going to give you -7n. Then n divided by 2 multiplied by 8n is going to give you what? Plus 4n squared. So just rewriting it, Sn is going to be equals to 4n squared minus 7, which is exactly like this one. So now let's do the last question for this section, the arithmetic sequence and series. So it says, this is a 2014 paper. So it says, given that the arithmetic series is 2, 9, 16 up to 251 terms, right? Then they say write down the fourth term. So first thing first, let's find the difference. So to find the difference, you know the drill. Is the second term minus the first term. So it's going to be 9 minus 2, which is going to give you 7. Then just to check whether it's truly 7, we're going to take the third one minus the second term. So it's going to be 16 minus 9. We see the fact that it's 7. So our difference is truly 7. So D is going to be equals to 7. Right? So now to get the fourth term, which is 2.1, to get T4, right? We're just going to add the third term plus 7, right? So it's going to be 16 plus the difference, which is 7, which is you're going to get 16 plus 7, which you're going to get as being 23. So that's the first answer. Then 2.2, right, it says calculate the 251 term in the series. So we need T250 1. So we need T251. So I'm going to use the general formula here. So we know that the general formula is Tn is equals to A plus n minus 1, then multiplied by D. We need A and D, and we already have n as being 251. So let's substitute. Our A is the first term, so it's going to be 2 plus n is going to be 251 minus 1. Then our D is what? Is 7. Punch that into the calculator. When you punch that, it's going to be 2 plus, open bracket, 251, right, minus 1. Then it's going to be multiplied by 7, which is going to be what? It's going to be equals to 1,751. So it's going to be 1,752, not 51. So that's what you're going to have as being your T251. Then they say express the series in terms of sigma notation, meaning we need to write it like this. That's what we mean. So but to do that, we need to find Tn, the general solution. So 2.3 is going to find Tn. So Tn is going to be equals to A plus n minus 1 than D. We're finding it in terms of Tn. So it's going to be, our n here is going to be what? It's going to be, sorry, Tn is going to be equals to, our A is going to be 2 plus n minus 1. Then our D is going to be 7. Solve this, is going to be Tn. Distribute the 7, is going to be 7 plus 7n minus 7. Then 2 minus 7, you're going to get negative 5. So Tn is going to be equals to what? It's going to be equals to 7n minus 5. That's how it is. Then you can check whether it's correct or not. Always remember in your exam, on your test paper, always check whether your Tn is correct or not, right? Then what you're going to do is, now we're going to write our Sn in terms of sigma notation. So it's going to be sigma. The number that goes here is the number of terms, the last number of terms, which is going to be what? 251. Then it's going to be n is equals to what? We're going to start at 1, right? Then here, open bracket, we find, you put the general formula. So it's going to be 7n minus 5. So that's the answer for 2.3. Let me go up so we can answer other questions. Then it says calculate the sum of the series, right? So we're looking for Sn. So we know the fact that Sn, I'm going to use the one with the first term and the last term, because of already we calculated what is T251, which is we got as being what? 1,752. So I'm going to use the one with the first term and the last term, which is going to be n divided by 2. Then it's going to be A plus L, right? So we know the fact that our n is what? Is 251. So it's 251. So it's going to be S251, right? It's equals to 251 divided by 2. Then our first term is going to be 2 plus our last term is going to be 1,752. Punch that into the calculator. You're going to get your Sn as being what? As being this value. 22. It's going to be this value. Right? Then now moving on to the last question. It says, if you notice, we already did it in one of the papers. I forgot which one is it. I think it's 2016. We did the one that says divisible by 5. Same concept. We're gonna have to write them down and take out the values that are already divisible by what? Divisible by 4 in our case, right? Then look for the last term that is divisible by 4. I hope I'm making sense. Then calculate everything. But let me just do it and stop rambling. So they say how many terms in this series are divisible by 4. So what we're gonna have is, I'm gonna write the series down. Then I'm gonna take 3 terms that are divisible by 4 to create another series, right? So that I can find the difference and find how many terms they are. So we have 2, we have 9, right? We have 16, Then when we add 16 plus 7, so if we say 16 plus 7, we have 23, right? Then plus another 7, it's 30, right? It's 30. Then another 7 is 37. Then another 7 is 44, right? Then another 7, like let's check. So we know the fact that 2 divided by 4 is not going to be divisible by 4. So that one we can't do, 9 can't do. But if we say 16 divided by 4, we're going to get 4. So 16 is divisible by 4, right? Then 23 is not divisible by 4. Then 30, if we say 30 divided by 4, it's not divisible by 4 too. But also 37 is not divisible by 4. But if we say 44 divided by 4, we're going to get 11. So we see the fact that 44 is divisible by 4, right? Then now we need the last term, 4, so that we can create a series so that we can find the difference within them, right? So if I say 44 plus 7, right, I'm going to get 51 here. So I'm going to get 51, right? Then plus 7, I'm going to get 58, right? Then plus another 7, I'm going to get 60. So if I say 58 plus 7, I'm going to get 65, right? Then plus 7, I'm going to get what? I'm going to get 72. So let's check. 51 is definitely not divisible by 4. 58 is not divisible by 4. 65 is not divisible by 4. But if I say 72 divided by 4, I'm going to get 18. So 72 is divisible by 4, right? So I know the fact that the 3 terms that we have is going to be 16. It's going to be plus 44, right? Then plus 72, right? Then we know the fact that the last term here is what? Is 200. It's what? The last term is, we have how many terms in total? We have 251, and that last term for 251 is 1752. So I'm going to check the fact that 1752 is a divisible by 4. So if I take that and divide it by 4, I get the fact that it is divisible by 4. So the last term, that is T55, is divisible by 4. So that is, in our case, that's going to be our last term, right? So let me just write it down here. So we know the fact that the last term is going to be what? Plus till the last one is 1752. I hope I'm making sense. With the previous one, the last term was not divisible by 5. That is why we needed to go terms forward so that we can find the last term that was divisible by 5. In our case here, the last term, which is 1752, is divisible by 4. So therefore, in our new series, right, that is divisible by 4, our last term is going to be the same last term as the original series. I hope that made sense, right? So now let's find the difference so we can find what is our n, how many terms are there that are divisible by 4. So if we say 44 minus 16, because we're looking for the difference, we're going to see the fact that it's going to be what? 28, right? And just to check, if we say 72 minus 44, we're going to see the fact that it's 28. So here our difference is what? Is 28. So we're going to look for the n term so that we can know how many terms are there that are divisible by 4. So we're going to use Tn, right? It's equals to a plus open bracket n minus 1 multiplied by d. Then our Tn is this one, right? So it's going to be 1752 is equals to, our a is going to be 16 plus our n is the one that we're looking for. So it's going to be n minus 1, then multiplied by our d, which is 28, right? Then solve this, take the 16 to the other side. So it's going to be 1752 752 minus 16, which is you're gonna get 1736, right? Then that's going to be equals to n minus 1 multiplied by 28, right? Divide both sides by 28, so it's going to be divided by 28, which is going to get 62. So you're going to have 62 is equals to n minus 1. Take the 1 to the other side, so therefore n is going to be equals to 63. So that means the fact that in total there are 63 terms, right, that are divisible by 4. So that's what it means. So we found how many terms that are actually divisible by 4. So that's the end of arithmetic. So now we're gonna go to doing quadratic. So now let's start with the quadratic sequencing. We're gonna start with quadratic sequencing notes. So the thing that you need to know about quadratic sequencing, the first point is that the common second difference the common second difference between any two consecutive terms are equal. So what happens, what this statement means, for example, let me give you a quadratic sequence and basically show you what this statement means, right? So for example, you have 1, you have 2, you have 4, you have 7, then you have 11, right? So this is the quadratic. Then the first difference, which is going to be this one. So you're going to say 2 minus 1, which is going to give you 1. Then you're going to say 4 minus 2, which is going to give you 2. Then you're going to say 7 minus 4, which is going to give you 3. Then you're going to say 11 minus 7, which is going to give you 4. So this is called what? The first difference, right? Then you're gonna have the second difference, which is the one that's going to be common, which is common means the fact that it's the same throughout, right? So if you say 2 minus 1, it's going to give you 1. If you say 3 minus 2, it's going to give you 1. And if you say 4 minus 3, it's going to give you 1. So this is the what? The second common difference between two consecutive terms, meaning between two consecutive terms. This one, right, is between 1 and 2, which is two consecutive terms, meaning they follow each other. I hope that made sense. So this is what this statement means. It means the fact that a quadratic sequence has a second common difference. So the first one is going to be like a quadratic. Then when you do when you find the difference, the second one is going to create a linear or a dramatic sequence. Then the last one is going to be the common difference, making the second one what? The second common difference, meaning it's the same throughout the second one, and the first one is just going to be a linear pattern or arithmetic sequence. I hope that made sense. So now moving to the second point, which is the general formula. Which you know as being Tn. So here Tn is going to be equals to an squared, right, plus bn plus c. Then what do we need to do? We need to find, to make this complete, we need to find a, we need to find b, and we need to find c. So I'm going to write the formulas for finding a, b, and c. So taking the previous example, so it's going to be 1, right, 2, 4, 7, and 11. Then we know the fact that we're going to have our first difference, right, which was 1, 2, 3, 4. Then we're going to have our second difference, which we had as being 1, 1, 1. For finding A, B, and C, what matters is this. Only the first terms in the difference. So from the quadratic, this one matters. From the first difference, the first term, right, matters. The first difference matters. And the last one is the first term, which is the same throughout, that matters. So to find the formula is going to be, we start from the bottom when we solve. So it's going to be 2a is equals to 1, right? Then here, this is going to be equals to what? It's going to be 3a plus b is equals to 1. Meaning after finding a here, you're going to substitute here to find b. Then here top is going to be a plus b plus c to find 1. So we're going to substitute the a from this one, the b from this one, and to find c. So let me just solve it and find the general solution here. As I say, the fact that we're going to start with 2a, so we're going to say 2a is equals to 1. Therefore, a is equals to 1 over 2, because I divided both sides by 2. Then, to find b, you're going to take the formula. And remember that the formulas are the same throughout, right? It's the same formula, only this ones are going to change. So you're going to say what? 3a plus b is equals to 1. Then you're going to substitute what? We're going to substitute a as we know as being a half. So you're going to say 3 open bracket 1 over 2 plus b is equals to 1. This is the same as 3 over 2 plus b is equals to 1. If you take 3 over 2 to the other side, right, b is going to be equals to what? It's going to be equals to minus 1 over 2, right? Then now solving for what? Solving for c. We know the fact that for the last equation, so we use this one, right? We already used this one. So to find c, we need to use this one. So we're going to say a plus b plus c is equals to 1. Substitute your a and b. So it's going to be what? It's going to be 1 over 2 minus your b is minus 1 over 2 plus c is equals to 1. Therefore, 1 over 2 minus 1 over 2 is 0. So therefore, c is equals to 1. Making our Tn now, we know the fact that a is a half, b is negative a half, and c is 1. So making Tn equals to what? We know that from the general solution, let me go. Yeah, we know the fact that a, it starts with a, so it's going to be our a is a half. So it's going to be 1 over 2 n squared, right? Minus, remember b is minus 1 over 2 n, then c is 1, so plus 1. So that's going to be your general solution. Then the last point that I want to point out is just a point, something that you need to know if they tested through using graphs, is that actually the knowledge that you need to know, because of you're going to see there's going to be some questions that needs the knowledge of you knowing what type of a graph this is, right? Is that a quadratic sequence is what? Is the graph of a quadratic sequence, right? Is a parabola, or it's a quadratic function. Graph the lies on a parabola, or you can just say the fact that a quadratic graph, because parabola is a quadratic graph. So this is a quadratic function. The general solution, this one, Tn, right? When you sketch it, it creates what? It creates a quadratic graph or a parabola. So that's what you need to know as being note. So now let's move on to the questions. So now looking at this 2021 question, it says This is question 3. Remember, this is from a paper 2021. It says, consider the quadratic number pattern. Remember, when you're doing number patterns, as you've seen with me doing the linear or the arithmetic, is that they do state which pattern it is. So you don't need to do trial and error checking which pattern it is, right? In the question, they do state. It said, consider the quadratic number pattern. Then they give you negative 145, then negative 122, and negative 101. Then they say the first one, we need to find what? T4. So it's two ways. It's either you can just find the difference, meaning taking the sequence, right? So it's going to be negative 145, then it's going to be negative 122, or you can say negative 101, right? Then find the first difference. So you're going to say negative 122 minus negative 145. Remember here when you're finding it, right, to find this one, because if we're dealing with negatives, and I feel like a lot of people are going to do a lot of mistakes here, you're going to say negative, right, 122, which is the second term, minus, remember it's minus, but this term is also minus, so it's minus 145. So when you're putting in the calculator, remember to put negative 145 inside a bracket, and remember the fact that there's two minuses. I hope that makes sense. So doing that, you're gonna get that negative 45 minus open bracket minus 45 is gonna give you 23, right? Then negative 101 minus, remember, open bracket minus 122 is going to give you 21, right? That's your first difference. Then we need to find our second difference, which is 21 minus 23, which is going to give you negative 2, right? It's either from here, you can just jump into the third question by finding the general solution, right? Or you can just add your negative 122, add 21 and add 22. So let me just do that one. So here to find our T4 is going to be the one that I'm going to do in pink. It's going to be negative 101, right? Let me just move the screen. It's going to be negative 101 plus what? Plus 21. Remember, we need to add plus 21. Then plus negative 2, right? So when you punch that into the calculator, what you're gonna get? You're gonna get what? You're gonna get negative 81. Sorry, not negative 81, but negative 82. So that's how you would find the next term, right? So this would be T4. So that's the first answer. So we know the fact that I'm just going to write the solution here. The 3.1 is equals to T4 is equals to negative 82, right? Or you could have just used Tn, meaning using this formula of Tn to find what? To find the fourth term. You could have just used either or, right? Then the second question says, show that the general term of this number pattern is Tn is equals to negative n squared plus 26 n minus 170, right? So what we need to do is we need to find the general solution. So 3.2 Tn, right, is equals to an squared, right, plus bn plus c. So we need to find a as being negative 1 here, looking at it. Then we need to find b as being positive 26 and c as being negative 70. So we need to use this pattern that I just created to solve for this. So remember what I said, the fact that to find the general solution, we use only the first terms. So the one I'm circling. So starting from the bottom going up, we know the fact that the formula for the second term is 2a is equals to negative 2. Then we know the fact that here is 3a plus b, right, is equals to 23. Then here on top is going to be what? It's going to be, let me just write it here, it's going to be a plus b plus c is equals to what? To negative 145. Hold that because I need space. Remember those formulas, right? Then now we're going to solve for a, b, and c, right? So we know the fact that 2a, right, is equals to what? This is 3.2. So we know that 2a is equals to negative 2, right? So a is going to be equals to what? To negative 1, right? Meaning from there it's correct. Then we know the fact that what? 3a plus b is equals to what? To 23. Substitute a, you're going to have 3, open bracket, negative 1, plus b is equals to 23. This is the same as negative 3 plus b is equals to 20. Is equals to 23. Let me erase this. Is equals to 23. Take the negative 3 to the other side. Therefore, b is going to be equals to 26. Then the last one is going to be what? It's going to be a plus b plus c is equals to what? Is equals to negative 145. Substitute your a and b. It's negative 1 plus 26 plus c is equals to what? Is equals to negative 145. Then negative 1 plus 26 is going to give you 25 plus c is equals to negative 145. Take 25 to the other side, therefore making c equals to negative 70, right? So we know from the equation that we had our tn, they already solved it as being negative n squared, right? Plus 26n minus 170, right? If you forgot, let me just go show you. See? And we see the fact that after solving, this is exactly the same when we substitute our a, b, and c. So our second question is done. So the third question says between which two terms of the quadratic number pattern will be a difference of negative 1, which equals negative 121. So the minute key something that you need to know, something that you always need to remember so that you can know which one to use. The minute they talk about which two terms, or when they say two consecutive terms, remember the fact that the general solution that you need to deal with is the second difference. They actually gave you what you need to use, the second difference, to find whatever answer that they want. If they say which term is, then they give you the value, then you're dealing with what? You're dealing with the first difference. When they want two terms, they're talking about the second difference, because of the second difference gives you the quadratic function. I hope I'm making sense. So see two consecutive something or two terms that you need to write. Remember what to use. You need to use the second term. And remember, as I said, that the second term of a quadratic is an arithmetic. So you need to use the general solution of an arithmetic, right? With that said, is that we know the fact that the arithmetic, we have this. Let me just rewrite the quadratic. We have negative 145. Right? Then we have negative 122. Then we have negative 101. Right? Then we have the first difference, which is 23, 21. Then the second difference is going to be negative 2. When they say two consecutive terms, right, what they mean is that we need to use, not what they mean, but is that we need to find whatever they're asking us using this sequence, which is, this one is what? Is a linear. I hope I'm making sense. We need to use the second one to find our answer. Hope I made sense. So with that said, we need to find Tn, right? Tn of an arithmetic is what? Or of a linear is a plus n minus 1 then d, right? So what do we know? We know the fact that they gave us Tn, which is negative 121. So it's going to be 121 is equals to our A is going to be from the first difference, which is 23. So you're going to say 23, right? Plus open bracket, we're looking for n, 2 consecutive terms. You'll see how we get the 2 consecutive terms. So you're going to say n minus 1, then our D is negative 2, right? Take the 23 to the other side. So it's going to be negative 121 minus 23, which is going to give me negative 144 is equals to what? 2 n minus 1, open bracket, negative. Then you're going to say minus 2. Close the bracket. Divide both sides by negative 2. When you do that, you're going to get that you're dividing both sides by negative 2. Therefore, this side is going to be what? It's going to be 72, right? Positive 72 is equals to n minus 1. Take the minus 1 to the other side. You're going to have your n as being what? As being 73, right? When they say 2 consecutive terms, your 2 consecutive terms is going to be 73 plus the next term, which is going to be and 74. So always when they say 2 terms or 2 consecutive terms, remember to use the first difference to find whatever they want from you. Always. Key. It always works. Then the next term, after finding your n, the next term is going to be the next term after whatever you found. In our case, it's 73. So the next term, that's why I said 2 consecutive terms, because of its terms that follow each other. So the next term is going to be what? It's going to be 74. So regardless whether do they say the fact that consecutive terms, when you see 2, remember the fact that you need to use this. Okay, so now let's move on to the last question. So now moving to the last term, they say what value must be added to each term in the number pattern so that the value of the maximum term is the new number pattern will be 1. Remember, they're talking about the maximum. They want the maximum number pattern to be what? To be 1. They want it to be that. Maximum, I remember the fact that in the notes, I did state the fact that a quadratic number patterns, when you graph Tn, it gives you what? It gives you a quadratic graph or parabola, right? Using that knowledge, the maximum, what you need to going to use the formula for a maximum, right? To find the maximum is the turning point. Remember the fact that the maximum is the turning point. So we're going to find the turning point of this graph. I hope I'm making sense. So maximum is the turning point. The least is if they say find the least term, is also the turning point, right? So to find the turning point, you need n. Normally you need this function, which is x is equals to negative b divided by 2a. But now our Tn, right, our graph is in terms of n, which is we have as being what? As negative n squared plus 26n minus 70, right? So we're going to find n we're going to substitute n instead of what? Instead of x. So we're going to say n is equals to negative b, because everything is in terms of n, divided by 2a. So our a here, remember when we solved it, our a is equals to negative 1. Our b is equals to what? Is equals to 26. Then our c is equals to negative 70, right? So substituting, it's going to be n is equals to b, which is going to be negative 26, divided by 2. Our a is going to be what? It's going to be negative 1. Therefore, making our what? Our n equals to 13. Remember the fact that our n is what? Is this n. So our maximum, see, they said what value. They didn't say which term is the maximum in the number pattern. They said what value. So we need to find T13, right? Because our n is our which term, right? So we need to find T13 so that we can know when can we do, what value can we add so that it can be 1. I hope I'm making sense and I'm not everywhere. So we're going to find T13 because of, let me just read the question again. They say what value must be added, right, to each term in the number pattern so that the value of the maximum term in the new number pattern is formed to be 1. So value, didn't say which term, but the value. So we found n, so we know the fact that t13, we need to find the maximum of this one, right, which is at t13. So we're gonna substitute 13, negative 13 all squared plus 26, right? Then it's going to be 13 minus 170. We see the fact that it's going to give you what? Negative 1. So the maximum of this, right, of this Tn, or the general formula, is negative 1. That's that maximum. But they say what term can we add? How much? So that we can get negative 1. To get positive 1, we need to add by 2. Because when we say negative 1 plus 2, it's going to give me 1, which is going to form the new maximum for the new one, so that the maximum is actually 1. So in this formula, right, if we add by 2, our maximum of this, the question that they're asking, is going to be actually 1. So the answer is that we need to add by 2, so that the new maximum for the new general solution is actually 1. I hope I made sense. So now during 2020, so they say given a quadratic pattern, number pattern, negative 3, 6, 27, and 60. Let's write down the number pattern on the side. Negative 3, 6, 27, and 60, right? So let's find the first difference and the second difference, then we'll go and answer the question. So it's going to be 6 minus 3, which is going to give you what? 6. Remember here, it's going to be what? Let me just show you again. It's going to be 6 minus, right? But remember the first term is a negative, so minus again 3, which is going to be the same as 6 plus 3, which is going to give you 9, right? Then the other one is going to be what? It's going to be 27 minus 6, right? So it's going to be 27 minus 6, which is going to give me 21. Then it's going to be 60 minus 27, which is going to give me what? Which is going to give me 33. This is the first difference, which is a linear. Then now let's find the second difference. So when you say 21 minus 9, it's going to give me 12. And when you say 33 minus 21, it's going to give me 12. So this is the first difference and the second difference. So now let's go and answer the question. So the first one says, determine the general solution in the number pattern in the form of Tn is equals to a n squared plus b n plus c. So here we need to find a, b, and c. So remember, to find a and b and c, we use the first terms of the first terms of each part. So here we use the first term of the quadratic. Here we use the first term of the first difference, and here we use the first term of what? Of the second difference. So we start from the bottom going up. Let me put this picture on the side. So what we're going to do is going to be 2a is equals to 2a is equals to 12, right? Here's going to be what? It's going to be 3a plus b, and the last one is going to be is equals to 9. Then the last one is going to be a plus b plus c is equals to negative 3. We start by solving 2a. So if we say 2a is equals to 12, divide both sides by 2. Therefore, our a is going to be equals to what? It's going to be equals to 6, right? Then the second one, which is going to be 3a, right, plus b is equals to 9. Substitute a, which is 6. So it's going to be 3, open bracket, 6, plus b is equals to what? Is equals to 9. Then multiply those two together and take it to the other side. It's going to be b is equals to what? Is equals to negative 9, right? Then to find c, it's going to be what? It's going to be a plus b plus c is equals to what? Is equals to negative 3. I hope you can see it here on the top, is equals to negative 3. Substitute your a and b, is going to be 6 for a, then for b is negative 9, plus c is equals to negative 3. Take 6 and negative 9 to the other side, making your c be equals to what? Be equals to 0. Right? So now we know the fact that Tn, because now we have a, b, and c, we know the fact that Tn, which is equals to an squared plus bn plus c. Substitute your a, b, and c, so it's going to be Tn is equals to what? It's going to be equals to 6n squared, right, minus 9n, and c is 0, so we're not going to write it. So this is going to be your Tn. So for 2.2.2, it says calculate the value of the fifth term of the pattern. So what we're looking for, we are looking for T50, right? So we already have the general term, so we can use the general term. So wherever I see n, I'm going to substitute by 50. So it's going to be equals to 6, open bracket, 50, all squared minus 9. Punch it into the calculator. T50 is going to be equals to what? T50 is going to be equals to 14,550. So now 3.2.3, it says, show that the sum of the first n terms, first difference of the number pattern can be equals to what? Can be equals to Sn, and they give you that. So remember they say what? Show that the sum of the first n terms, or what? First n terms, meaning the last term is n of what? Of the first difference, right? Not of the quadratic, but the first difference. So let me rewrite my pattern. So it's negative 3, remember, it's 6, it's 27, and it's 60, right? So we remember that our first difference was what? Was 9, was 21, and it was 33. Then the common second difference was what? Was 12. So now what they're looking for? They're looking for Sn of this one, of the first difference. Not the quadratic, but the first difference, which is a linear. Remember I said the fact that this is a quadratic, and when you find the first difference, the first difference is a linear. So we're gonna use what? The sum of a linear. I hope I'm making sense. So Sn, right, is going to be equals to, the formula is going to be n divided by 2, open bracket, 2a plus n minus 1, then it's going to be d, right? So here our a is the first term in the first difference, not the quadratic, but the first difference, because it's specific to the first difference. So a here is equals to 9, then our d is equals to what? Is equals to 12. So we know the fact that we're looking for what? The sum of the first terms of n, knowing the fact that our last term is going to be n. So n is going to still remain as being n. So it's going to be Sn is equals to n divided by 2. Then substitute a. So a, right, is 9 plus n minus 1 remains the same. Then our d is 12. Right? So now let's simplify the inside bracket. So it's going to be Sn is equals to n divided by 2. Then 2 multiplied by 9 is going to give me 18. Right? Then when we distribute 12 into the bracket, it's going to be plus 12n minus 12, right? So 18 minus 12 is going to give me 6. So Sn, then it's going to be n divided by 2. So here what's going to be left is going to be 6 plus 12n, right? Then distribute the n divided by 2. So therefore Sn is going to be equals to what? It's going to be equals to 3n, right? Then it's going to be plus 6n squared. Rearrange it the way it is here. So we're going to have that Sn is equals to 6n squared plus 3n. So you have exactly what you're given here. So that will be the answer for 2.2.3. So now moving to 2.2.4, it says how many consecutive, right, first difference were added to the first term of the quadratic number pattern, right, to obtain a term in the quadratic, remember, in the quadratic number pattern that has a value of what? Of 21,060. So remember here, what value did they give us? They gave us the value of the first one. Remember the fact that our pattern is like this, right? -3, 6, 27, and 60. Then obviously we have the first difference, which is going to be what? Which is going to be 9, 21, right, and 33. And the second difference, which is going to be 12. So here they said obtained a term in the quadratic number pattern that has a value. This is the quadratic, right? So this is the quadratic, and this is what? The first difference. So this is the first difference, right? And this is the second difference. So you need to understand that so that we can know which formula to use. So here they gave us the value of what? Of the quadratic. So what we're going to use? We're going to use our Tn to actually solve the how many terms were there. I hope I'm making sense. So what you're going to do is you're going to say, we know the fact that Tn is equals to what? Is equals to 6n squared, right, minus 1. I hope I'm making sense. Then what we're going to do, I'm going to answer how many consecutive first terms. I'm going to answer it after. Now I'm looking for the n here using whatever we given, because if they gave us the quadratic number pattern that has a value of 21. So I'm finding the value first, the n term, using the fact that we already given that the value is 21,060. So Tn is going to be substituted by 21,060, and we're looking for n. So it's going to be 21,060, right, is equals to 6n squared minus 9, right? So now we're going to take the 21,060 to the other side. So we're going to have 0 is equals to what? To 6n squared minus 9, right? Minus 21,060, right? Then divide everything by 3. So you're going to have, this is n, mistake. So you're going to have 2n squared, right, minus 3n, then minus 7,020, right? So here I'm going to use quadratic formula. So when I use quadratic formula, let me go up. I know the fact that n, remember everything is in terms of n, so I can say x. So you're going to say n is equals to what? To negative b plus or minus square root, then it's going to be b squared minus 4ac, right? This whole thing is going to be divided by 2a, right? So here we need to find our a, b, and c. So a here is going to be equals to 2, b is going to be equals to negative 3, then c is going to be equals to negative 7,020, right? So now substitute a and b. So when we substitute a, b, and c, we're going to have minus 3, right, plus or minus square root. It's going to be 1. It's going to be negative 3 all squared minus 4. Our a is 2. Then our c is negative 7,020, right? And this whole thing is going to be divided by what? By 2, multiplied by 2. Then when here you substitute by a negative, when you start with the negative, punch this whole thing, but it's a negative first. You're going to find that n is going to be equals to negative 17 over 2, or n, when you substitute, now we replace the negative by a positive in the formula here, because you see it's a plus or minus, you're going to have that n is equals to 60, right? So we know the fact that n is equals to what? To negative 17 over 2, and n is equals to 60. This one is not applicable, so the one that's applicable is n equals to 60, but that's not the final answer. So we know, I'm going to write it pink, we know the fact that from the calculation you had n is equals to 60, right? So remember here, they say how many consecutive first difference, right, were added to the first, this is the important part to have your final answer, the first term of the quadratic number pattern. So you know the fact that to find the first difference, you have two consecutive, right? You have two consecutive terms. This is T1, this is T1 and T2. Here you have T3 and T4. To find 9, you have T1 and T2, right? And here to find 21, you have what? You have T2 and T3. And here to find 33, you have T3 and T4. So what do they want? They want the first term of what? Of adding up the first consecutive terms, right? So they want the first term. So the 60 is the second term. So your answer, therefore, is going to be that n is equals to what? To 59. Because remember, they are consecutive. So the one before it is going to be what? Your answer, because of they said the first term. I hope I made sense. So your answer here is going to be n is equals to 59, because they specifically said the fact that were added to the first term of the quadratic number pattern, right? So your answer is going to be n is equals to 59. So now moving to 2019, question 2, it says the quadratic sequence, then they give you 321, 290, 261, and 232. Then let me write it down first before we answer question. We have 321, we have 290, we have 261, and we have 234. Let's find the first difference, right? So we know the fact that 290 minus 321 is going to give me negative 31. 261 minus 290 is going to give me negative 29. Then 234 minus 261 is going to give me negative 27. Now let's find the second difference. Remember that you're dealing with negatives, so when you find the difference is going to be negative 29 minus open bracket minus 31, right? So when you put this in your calculator, don't forget to put a bracket to put the other term inside the bracket so that you can find the proper number. So when you say negative 29 minus opening bracket negative 31, it's going to give me what? It's going to give me 2. Then when you do the same thing with negative 27 minus, then open bracket minus 29, it's still going to give me 2. So remember to always do this, guys, because of this is what makes a lot of students get like this type of questions wrong, by not putting the bracket, and you end up getting the wrong difference. So it says the first one, write down the first two terms. Before I do that, I'm going to skip to 2.1.2. Remember, in an exam, you can actually start with any question that you like. So it really doesn't matter. So it's going to be 2.1.2, right? So they're looking for Tn. Remember to find Tn. These are the important values so that you can find your Tn. We start from the bottom. It's going to be 2a is equals to 2. Then here's going to be 3a plus b is equals to negative 31. And here's going to be a plus b plus c is equals to 321. So let's solve for 2a. So we know the fact that 2a is equals to 2, right? Therefore, a is equals to what? Is equals to 1. So we're going to have 3a, right, plus b is equals to negative 31. Substitute your a, so you're gonna have 3 open bracket 1 plus b is equals to negative 3. Therefore b is going to be equals to what? Our b here is going to be equals to, so sorry, this is negative 31. So take the 3 to the other side, therefore b is going to be equals to negative 34, right? Then we're going to have a plus b plus c is equals to 321. Substitute your a, b, and c. So a is 1 and b is negative 34 plus c is equals to 321. Take everything to one side and leave c alone here. Therefore, c is going to be equals to what? To 354, making Tn equals to what? Equals to n squared, right? Substituting for a here, then our b is negative 34n, then it's going to be plus what? And our c is 354, right? So I am done with this question. So for the first one, which is 2.1.1, I can use this formula. So I'm going to say t. Remember the next two terms. This is t1, this is t2, this is t3, and this is t4, right? So the next two terms is t5 and t6. So I can find t5, which is t5 is equals to, using this formula, it's going to be 5 squared, right, minus 34. Then this is 5 here, plus 354. Punch that into the calculator. You're going to get that t5 is equals to what? Is equals to 209. Then t6, right, because they said the next two terms is going to be 6 squared minus 34. Then it's going to be 6 in here, plus 354. Therefore, when you punch that into the calculator, you're going to get the fact that t6 is equals to 186. So you're done with the first question and the second question. So now moving to 2.1.3, it says which term in bracket terms in the sequence will the value be 73. So we already know the fact that Tn, we're looking for the n in the Tn, right? So we know the fact that Tn is equals to n squared minus 34, right, n plus 354. So they say which term we're looking for n, right? So what we given Tn. So Tn in our case is 74 is equals to n squared minus 34n, right, plus 354. Take the 74 to the other side. So here it's going to be 0 is equals to n squared minus 34 minus 34n plus 354 minus 74. Then when you simplify the bottom part, what you're gonna have that 0 is equals to n squared, right, minus 34n, right, plus 280, right? So now using the quadratic formula, you're going to have n is equals to negative b plus or minus, and the square root, it's going to be so now substitute your a, b, and c. So a is equals to 1, b is equals to negative 34. I'm taking it from here. It's equals to negative 34. Then our c is equals to 280. Substitute that. So you're going to have n is equals to So when you punch it into the calculator, you're first going to start with negative. So n, when it's negative, is equals to what? Is equals to 14. Or n, when you substitute positive, it's going to be equals to 20. Since both our n's are positive, right? Since both our n's are positive, then both 14 and 20 is equals to Tn. So that is why they said the term or terms in bracket. So here we have two terms, which is n is equals to 14 and n is equals to 20. But if either one of them was a fraction or was a negative, we are not going to pick that one. But because of this is a positive whole numbers, both of the values are our n in this case. So T14 and T20 are both equals to 74. So that's what I mean in basic terms. So now moving to the last question, it says 2.1.4, it says which term in the sequence has the least value, right? So it has a turning point, which can be the minimum and it can be the maximum, and the least is basically the minimum, right? So here, to find the least term, what we need to do first is that we need to find the where is it position, which is n first, right? So after finding n, we're going to use that n to find the actual value, because if they said the least value, but they didn't say the least term, they said the least value. So after finding our n, we need to actually find what is the value at that position. I hope I'm making sense. So let me erase this. So first we're going to use what we're going to use for 2.1.4. We're going to use the formula of a turning point. So the formula of the turning point, we're going to have n. Remember, it's going to be x is equals to negative b divided by 2a. I'm going to use that. But instead of x, we're going to say n. So it's going to be n is equals to negative b divided by 2a. Remember the fact that we're going to use this formula, right? So here our a was what? Our a was equals to 1, and our b was equals to what? Was equals to negative 34. So here substitute our b and a. So we're going to have n is equals to what? It's going to be equals to negative, open bracket, negative 34 divided by 2, and this is 1. And when we solve that, our n is going to be equals to 17, right? Which works out perfectly because of n needs to be always positive, right? So this is the position. It's in position 17 where the least value is. So now they didn't want the term. This n here is the what? Is when you're looking for the term. This is for the term. We're not looking for the term, but we're looking for the value. So we need to find T17 because they said value, not term. So T17, then we're going to substitute the 17 into the general term, which is T17 is going to be equals to 17 squared minus 34, 17, right, plus 354. So when you punch this into the calculator, you're going to get that T17, what is the value? T17 is equals to, so T17 is going to be equals to 65. 65. So let me erase this. So T17 is going to be equals to 65. Remember, 17 is the position, which is the term where it's situated, where that is the smallest value. Then T17, which is, I just calculated the 65, is the actual value. So the actual minimum value here is going to be what? Is going to be 65. So now moving to 2018, it says given that the quadratic sequence, which is 2, 3, 10, and 23. So you know the drill. Let's write it down. So we have 2, 3, 10, and 23, right? Then we're gonna find our first difference. So it's going to be 3 minus 2, which is going to give me 1. Then 10 minus 3 is going to give me 7. Then when I say 23 minus 10 is going to give me 13. Then the second difference, when I say 7 minus 1 is going to give me 6. And when I say 13 minus 7 is going to give me 6. So the first question, 2.1.2, it says write down the next two terms. I'm not going to start with that one. I'm going to start with the second one, which is they say determine the n term. So we're looking for Tn. So to do that, you know the fact that this is what you're going to use. So we know the fact that 2a is equals to 6, then 3a plus b is equals to 1. Then we know the fact that a plus b plus c is equals to 2, right? So now we're going to solve for a, b, and c. So let's do that. We know the fact that 2a is equals to what? Is equals to 6. Therefore, a is equals to what? Is equals to 3. Then we know the fact that 3a plus b is equals to 1. Substitute a, so 3 open bracket is going to be 3 plus b is equals to 1, therefore making b equals to negative 8. Then c, for solving for c, we're going to say a plus b plus c is equals to 2. Substitute our a and b. A is 3, then b is negative 8 plus c is equals to 2. Take 3 and negative 8 to one side. So we're going to have c is equals to what? Is equals to 7, right? So therefore our Tn is equals to what? This is for, remember, 3.1, this is for 2.1.2, right? So Tn for 2.1.2 is going to be equals to, we know the fact that it's going to be an squared, right, plus bn plus c. Substitute a, b, and c. So Tn is going to be equals to 3a squared minus 8n, then plus 7. So that's our Tn here. So now moving to 2.1.1. It says write down the next term. So here this is the first term, second term, third term, fourth term. So the next term here is going to be T5. So knowing that our general formula is this one, the one that we just calculated, we're going to be looking for T5. So this is 2.1.1, right? So T5 is equals to what? It's going to be equals to 3. Then wherever you see n, you're going to substitute 5. So it's going to be 5 squared minus 8 open bracket 5 plus 7. Punch that into the calculator. You're going to get the fact that T5 is equals to 42, right? So now 2.1.3, right? 2.1.3, it says calculate the 20th term. So we're looking for T20. So if I see n, I'm going to substitute by 20. So it's going to be 3 open bracket 20 squared minus 8, right? Then it's going to be 20 plus 7. Punch that into the calculator. What you're going to get 1047 as being T20. Then now what we're going to do is we're going to answer 2.3, right? We're not going to answer 2.2 because I already answered it in the arithmetic. So I'm going to answer 2.3 because it's a combination of quadratic and arithmetic. So 2.3, it says for which value of n, right? We're looking for how many terms basically. For which value of n will the sum of the first, let me highlight it, will the sum of the first n terms of the arithmetic sequence in 2.3, so they mean this one, right, will be equal to the n terms, right, of the quadratic, right, of the n terms of the quadratic sequence in 2.1. So what do they mean? They mean the fact that the first one, which value of the first terms of the sum of the first terms. Very important, meaning they mean for 2.2 is that Sn of 2.2. Let me write here. Translating the question in simple term, they mean the fact that Sn for 2.2, right, is equals to Tn of 2.1. Does it make sense? So they say they were looking for n when Sn of 2.2, which is the arithmetic, is equals to the Tn. See the n terms of the quadratic sequence. The minute they say n terms, they mean the fact that Tn, right? And the minute they say Sn, they mean Sn in the sum of, right? I hope I'm making sense. So it's Sn of 2.2, which is the arithmetic, is equals to the Tn of 2.1, which is the quadratic. That's what they mean. So I need to find Sn for what? For 2.2. Then we have already calculated Tn. So let's do that. Let's find Sn. So we know the fact that I'm going to do it in pink. So this one is going to be the one in pink, right? So that you can see it. So we know the fact that the general, not the general terms, but the terms is 34, right? Is 28 and is 21, right? Then the difference here is going to be 28 minus 34, which is going to be negative 6. And when you say 21 minus 28 is going to give you negative 6. So we're looking for Sn. So we know the fact that Sn is equals to what? Is equals to n divided by 2, open bracket, right? It's going to be n divided by 2, then it's going to be 2a plus open bracket n minus 1, right? Multiplied by d. So we need a and d. So our a is going to be 34. And our d is going to be negative 6, right? So it's going to be negative 6. So we're going to substitute. So Sn is equals to what? It's equals to n divided by 2, right? Then it's going to be 2, open bracket. Our a is it's 34, not negative. It's not 34. Sorry, it's 35. So, sorry, the first term is not 34, it's 35. So our difference changes to, so it's going to be 35, right? Then our difference is negative 7 and negative 7. So our first term is going to be 35. So it's going to be 35, right? Then it's going to be plus n minus 1. Then our difference is going to be negative 7. Simplify the brackets inside. So Sn is going to be equals to n divided by 2. Then you're going to have 2 multiplied by 35 is going to give me 70. Then distribute the negative 7. So you're going to have negative 7n plus 7. So simplify it more. So it's going to be n is going to be equals to what? To n divided by 2. Then it's going to give me 77, right? Minus 7. Then I'm going to distribute the n divided by 2. So therefore, I'm going to have Sn is equals to what? It's going to be equals to 77 divided by 2n, right? Minus 7 over 2, right? Divided by n squared. So that's what I'm going to have. So now I know the fact that the question it said Sn, right, is equals to Tn. So Sn of the arithmetic of 2.2, remember, and Tn of 2.1, right? So we already calculated Sn as being what? As being 77 divided by 2n minus 7 over 2 n squared. Then our Tn, we have Tn, we already calculated Tn as being 3n squared minus 8n, right, plus 7. So now take everything to one side. So I'm going to have 0 this side. Then I'm going to say 3n squared, right? Then plus 7 over 2 n squared, right? 7 over 2 n squared. Then it's going to be minus 8, right, n. Then it's going to be minus 77 divided by 2n, then it's going to be plus 7. Simplify this, so you're going to have 0 is equals to 13 divided by 2 n squared, right, minus 93 divided by 2n, right, plus 7. So now what I'm going to do is I'm going to use the quadratic formula to solve for n. So n is going to be equals to the quadratic formula. So remember here, a is going to be equals to 13 divided, it's going to be equals to 13 divided by 2. Then b is going to be equals to 93 divided by 2. Then our c is going to be equals to 7, right? So substitute a, b, and c. So n is going to be equals to what? It's going to be equals to minus, right, open bracket, negative 93 divided by 2, right, plus or minus, then substitute everything inside. Then this is 2a. So when you substitute the negative inside, you're going to find that n, right, is equals to 2 over 13. And when we substitute positive, you're going to see that n is equals to what? It's equals to 7. Therefore, our n is equals to 7. So n is equals to 7. So for the Sn, for the sum of the arithmetic to be equal to be what? To be equals to the general term of the quadratic, it needs to be n is equals to 7. It's the 7 term that both the two are equals to each other. So this is the end of 2018. So now moving to 2017, it says given the following quadratic number pattern, they give you 5, negative 4, negative 19, and negative 40. So let me just write here to find my first difference, second difference. So it's going to be 5, negative 4, negative 19, and negative 40, right? So the first difference is going to be negative 4 minus 5, which is going to give me what? Which is going to give me negative 9, right? So the second one is going to be negative 19 minus, open bracket, negative 4, close the bracket. Remember, because we're dealing with the negative when we find this one. So it's going to be negative 19. I'm not repeating this because of for fun, guys, because people make a lot of mistakes when it comes to this. Minus 4. Remember, when you punch it into the calculator, don't forget the bracket. So when you do that, you're going to find the fact that it's negative what? Negative 15. Then here it's going to be negative 40 minus, open bracket, negative 19, close bracket, which is going to give you negative 21. Even here, you're going to use your brackets because of their all negative, right? So you're going to have what? When you say negative 15, open bracket, negative 15 minus, open bracket, negative 9, it's going to give you negative 6. Same when you do this, negative 21 minus, open bracket, negative 15, it's going to give you negative 6, right? So the first question, 2.1.1, it says, let me answer it, 2.1.1, it says determine the constant second term. So the second term is equals to negative 6. So this is the second term. It's constant because of it's the same, and it's the second difference. So 2.1.2, 2.1.2, right? So 2.1.2, it says determine the n term, right, which is Tn. So we need what? We need this. So let me circle them. So we know the fact that 2a is equals to negative 6. We know the fact that 3a plus b is equals to negative 9. And we know the fact that a plus b plus c is equals to 5. So let's solve for a, b, and c. So we know the fact that 2a, right, is equals to negative 6. Therefore, making a equals to what? A equals to negative 3. Then we know the fact that 3a plus b is equals to what? Is equals to negative 9. Then when we substitute a, is going to be 3, negative 3 plus b is going to be equals to negative 9. This is going to give you positive negative 9. Take it to the other side. Therefore, b is going to be equals to what? It's going to be equals to 0, right? Then you have a plus b plus c is equals to what? To 5. Substitute a and b. We know the fact that a is negative 3, b is 0, plus c is equals to 5. Therefore, c is going to be equals to 8, positive 8. So therefore, making our Tn equals to what? Equals to, we're going to substitute, remember it's going to be an squared minus bn plus c. So we're going to substitute a, b, and c. So a is what? A is negative 3, so it's going to be negative 3n squared. B is 0, so we're not going to write it. Then c is going to be plus 8. So Tn is going to be negative 3n squared plus 8. So now moving to 2.1.3, it says which term of the pattern will be equals to what? To negative 25,939. So what are we given? We're given Tn in the general term and we're looking for n. So let me write it. So we know the fact that we have Tn is equals to what? This is 2.1.3, right? So Tn is equals to negative 3n squared, right? Plus 8. So we are given Tn and we're looking for n because of they gave us the value and they're looking for the term. So they said which term. So we're going to say negative 25,939 is equals to negative 3n squared, right? Plus 8. Take the 8 to the other side. So you're going to have negative 25,947. Yeah, 47 is equals to negative 3n squared. Divide both sides by negative 3. You're going to get what? You're going to get 8,649 when you divide both sides by negative 3, which is going to be equals to n squared. Then now what we're looking for? We're looking for n alone. So square both sides. So when you square both sides, you're going to have the square root of what? Of 8,649 is equals to n. Remember, since the power is an even number, so it's going to be plus or minus, right? Since the power is an even number, so therefore you're going to have plus or minus what? 93, right, is equals to n. This is the same as saying n is equals to 93 or n is equals to negative 93. This and this is the same thing. So therefore, since remember n cannot repeat, n can never be a negative, therefore n is equals to 93. So your answer is when n is equals to 93. So now let's move to 2016. It says the first 4 terms in the quadratic number patterns, and they give you, then they want the first question to calculate for x. So let's write the terms here on the side, right? So we have negative 1, we have x, we have 3, we have x plus 8, right? So we need to calculate for x. So let me just put it aside. We know that the first difference here, let's find the first difference. So we're going to have x minus 1. So it's going to be the same as x because it's minus, minus 1. Then this one for the other one is going to be 3 minus x, right? Then here's going to be x, right, plus 8 minus 3. Let's simplify this part. So here we're going to have x plus 1. Then this one's going to remain the same as being x minus x. And the other one, when we simplify it, is going to be what? It's going to be x plus 5, right? So this is going to be what? This is our first difference. So remember the fact that the first difference is what? It's a linear or an arithmetic. So the second difference now is going to be what? It's going to be 3 minus x, right, minus open bracket x plus 1, right? Then here we're going to have what? It's going to be x plus 5 minus, it's going to be 3 minus x, right? So now simplify this. Is what you're going to get. You're going to get, okay, even if we don't simplify it. So this is going to be what? Our second difference. Second difference. So remember the fact that the second difference, they both equals to each other. Taking that into account, we're going to have 3, right, minus x, right, distribute the negative. So it's going to be minus x, then it's going to be minus 1. Remember, this is what? This is question 3.1.1. Yes. So we know the fact that this one, which is I just wrote here, is equals to this one, which is going to be 5 plus x plus 5, then distribute the negative. It's going to be negative 3, then it's going to be plus 1. Simplify that, right? It's the same as having negative 2x plus 2 is equals to what? To 2x plus 2, right? So when you take the 2x to the other side, you're going to have, when you take the 2x to the other side and you take the 2 to the other side, you're going to have negative 4x, right, is equals to 0. And therefore, x is going to be equals to 0. So our x here is equals to 0, right? So the first question is that x is equals to 0. Then the second one says if x is equals to 0, determine the position of the first term in the quadratic number pattern for which the sum of the n terms. Very important. Let me read that again. Let me read the question, then we're going to go back to analyze it. They say if x is equals to 0, determine the position of the first term in the quadratic number pattern, right? So we need the first term, right, in the quadratic number pattern, right? Then they give us more information for which the sum, right? So they say for which the sum of the n terms of the first difference, meaning this first difference, will be greater than Sn, right? So what we need to solve is that we need the first term of the quadratic, but what are we given? We're given the fact that Sn of the first difference, right, is what? Is greater than 250. So that's what we're given to solve the n, right? So now we need to look at it and find our number pattern in terms of now substituting x is equals to 0, né? So let me just go a little bit down so that we can do it properly in a clean slate. So now I took the pattern that we're given, and I substituted x as being 0, and this is what you're going to get, right? So we need Sn of the first difference, so they're talking about this, right? So I'm going to find Sn of the first difference. I know the fact that it's greater than 250, so let's find Sn. So we know that Sn, right, is equals to what? It's equals to n divided by 2. Then it's going to be 2a plus. So here I'm going to substitute my what? My a and b. My a, right, here is going to be 1 because we're looking at the first term, and my difference is going to be 2. So let's substitute. So now let's simplify the one inside the bracket. distribute the 2. So you're going to have Sn is equals to, simplifying the bracket, you're going to have, so the 2 are going to cancel out, you're going to have 2n, distribute the n divided by 2, therefore Sn is equals to n squared, right? So now we know the fact that Sn is equals to n squared. I'm going to substitute Sn by n squared, so this is the same as saying n squared is greater than 250, right? Then now I'm solving for what? I'm solving for n, so I'm going to square root both sides. So when I square root both sides, it's going to be n square root, right? It's going to be the square root. Remember, since it's the square, it's going to be plus or minus, so 250, right? So therefore n is going to be greater than what? Plus or minus what? Plus or minus 15, 8, right? But remember the fact that n should be strictly positive. This is the same as saying n is greater than 15, 8. So rounded off, n, right? N is going to be what? So to round it off, now to answer the question what they want, we know the fact that from 15 rounding off, meaning n, so that it can be greater than 250, the first terms. Remember, this is for the first terms. Remember, very important, this is for the first terms. So for the first term, the sum to be greater for this one, I'm being specific, for the terms, the first difference, so that the sum can be greater than 250, what needs to happen? N needs to be equals to 16. Then when you add up the first difference, n, what you call this, then your terms are going to be greater than 250, right? But we need what? We need to determine the position of the first term in the what? In the quadratic. So for the first difference, so n is equals to 16, right? When n is equals to 16, then it's gonna, therefore your Sn is going to be greater than what? Greater than 250. So this is for the first term. Remember, because we looked at Sn for the first term. But for the quadratic, which is the one here at top, n needs to be what? N needs to be equals to 17, so that when you add up the quadratic, the top part, therefore it's going to be greater than 250. I hope I'm making sense. N is equals to 16. When you add up the terms, it's going to be more than 250 for the first difference. But for the quadratic, n needs to be what? The next number, which is n is equals to 17. So this is your answer, n is equals to 17. When you add up for the quadratic, therefore when n is equals to 17 for the quadratic, the top part, not the second part, therefore your thing is going to be equals to what? Your sum is going to be greater than 250. So this is for the quadratic. So your answer is n is equals to 17. So you can be specific and say the sum of the first term. Let me write it down so that you can understand. This is for the quadratic. So I needed to just explain that. Let me write down so that it can make sense. It says the sum of the first difference, the first difference I don't know whether I spelled it right. The first difference will be, right, greater than 250, right, when n is equals to what? To 16, right? Full stop. Therefore, right, the 17th term of the quadratic, which is what I just explained before. Quadratic number. So for the first difference is 16, and when you add up 16 terms, it's going to give you greater than 250 for the first difference. But for the quadratic, when you add up 17 terms, it's going to give you what? Greater than 250. So that's what this statement means in simple terms. So now looking at 2015, it says another sequence is defined. So with this type of questions, you need to basically do a trial and error, meaning check whether is it an arithmetic, because they don't state whether it's an arithmetic, quadratic, or a geometric. So with this one, I know the fact that it's a quadratic, but what you need to do is that you need to test out whether is it arithmetic, quadratic, what you call is quadratic, or geometric. I know the fact that for a fact it's what? It's definitely a quadratic. So what I'm going to do is I'm going to add up here everything. So I'm going to say 6 here. So I know the fact that Q1, right, which is the first term for my case. So Q1 is going to be equals to -6, right? Then Q2, I'm going to add up -6 and -3, which is going to give me -9. Then Q3, do the same thing, add them up. It's going to give me -4. Then Q5, let me just move here. Q5 is going to give me what? When I add them up, no, Q4, sorry. Q4, when I add them up, I'm going to get 9. Then Q5, right? When I add them up, I'm going to get 30, right? So I'm going to find my first difference. So here it's going to be -9 minus open bracket -6. You know the rules that I kept on emphasizing, because if it's a negative, it needs to be inside a bracket. Here you're going to get -3. Then when you say -4 minus open bracket -9, you're going to get 5 here. Then when you say 9 minus 4 and 9 minus open bracket -4, you're going to get 13. Then the last one, when you say 30 minus 9, you're going to get 21, right? Then find the difference here. So when you say 5 minus open bracket -3, you're going to get 8. Then when you say 13 minus 5, you're going to get 8. And when you say 21 minus 13, you're going to get 8, right? So now we see the fact that it's a quadratic after finding it, right? Assuming that when you're in the test paper, you're going to do trial and error. So the first one, it says what? For 3.4.1, it says write down the numerical expression for Q6. So they're looking for the 6th term, which is in our case, they're not writing in T. What they're not representing it in T's, but they're representing it in Q's, right? So what I'm going to do here is that to make it easy, especially for the next question, I need to find T in, right? So let's find T in, right? So T in, which is in our case is not T in, it's Q in. So to find Q in, right, it's going to be n squared, a n squared plus b n plus c, right? So I'm going to use the first terms, this one, and this one, right? Since I don't have space here, I know the fact that 2a is equals to 8, right? And therefore a is going to be equals to 4. Then the other one is going to be what? It's going to be 3a plus b is equals to -3. Substitute a, so you're going to have a as being 4 plus b is equals to -3. Therefore my b is equals to what? Is equals to -15, right? Then you're going to have a plus b plus c is equals to what? Is equals to -6. Then substitute a, b, and c, so you're going to have 4 minus 15 plus c equals to negative 6. Therefore, take everything to one side. C is going to be equals to what? It's going to be equals to 5, right? Substitute your a, b, and c, right? So when you substitute your a, b, and c, you're going to have that qn, right? Qn is equals to what? It's equals to 4n squared, right? Minus 15n plus 5. That's what we have. So using that knowledge, I can find Q6, but remember the fact that they said I need to write it in numerical expression. I'm going to write it in numerical expression. So for 3.4.1, Q6, right, is equals to what? Substitute, when you see n, you're going to substitute 6. So you're going to have 4, then 6 squared, right, minus 15, open bracket 6, right, plus 5. So you're going to get the fact that it's going to be equals to 59. Very important. They said write it in numerical expression, meaning they want us to write it like this. So what do I need? I know the fact that I have all terms, but I need to add up by one term so that it can be in numerical expression. So we know the fact that what Q5 is equals to what? When I added it up is equals to what? Is equals to 30. So I know this. Let me just write it down here. I'm going to do it in pink so that I don't confuse anyone. I know the fact that Q5, right, is equals to 30 when I add it up. And I just calculated the fact that Q6 is equals to what? To 59. So before I write a numerical expression, I'm gonna see what's remaining from Q6, right? What did I add to Q5 to get Q6? That's what I mean. So I'm gonna say 59, which is Q6 minus 30, right? Which is gonna give me 29. So I added 29 to Q5 so that I can get Q6. So what do I know? I know the fact that Q5, right? Q5, the numerical expression for that is what? It's negative 6, negative 3, right? Plus 5, plus 13, right? Plus 21. So Q6 now, remember, it's going to be what? It's going to be everything from Q5 plus 29 because of I added 29 to Q5 so that I can get Q6. I hope I'm making sense. So it's going to be Q6. The numerical expression is going to be negative 6 minus 3 plus 5 plus 13, right? So repeating everything. Let me just move it here. Repeating everything plus 21. Then plus the one that I added from Q5 to get Q6, which is 29. So this will be your numerical expression. So the last question for 2015, it says calculate the value of Q 129. So here Q6 is equals to this one, which is negative 6, minus 3, right, plus 5, plus 13, plus 21, then plus 29, which is the 21 is the difference between Q5 and Q6. So now 3.4.2, it says calculate Q 129. So Q 129 using this general formula that I just found, which is this one. Wherever I see n, I'm going to substitute by 129. So it's going to be equals to 4, open bracket, 129 all squared, right, minus 15, 129, then plus 5, which is you're going to get your answers being 64,634. So that would be your answer. So now moving to 2014, it says given that the quadratic sequence, then they give us, so let me just write it down here. So let's find the first difference. So the first difference is going to be -6, -4, and it's going to be here. So this is going to be p minus 11. So it's going to be the same as p plus 11. Then the second difference, here it's going to be 2, and here it's going to be what? It's going to be p, right? Plus, it's going to be p plus 11 minus, open bracket, minus 4, right? So the first one, they say calculate the value of what? Calculate the value of p. So 3.1.1. We know the fact that the second difference are the same. So it's the same as saying p, right, plus 11. Then you can say plus 4 is equals to what? Is equals to 2. Then solve for p, therefore making p equals to what? Equals to 13. So that's your p. Then the second one, they say find what? Find the n term. So we're going to use this, remember? We're going to use this to find our n terms. This is what we're going to use. So this one is -1, remember? So to find our n term is going to be 3.1.2. It's going to be 2a is equals to 2. Therefore, a is equals to what? Is equals to 1. Then you're going to say 3a plus b is equals to -6. Substitute a. So it's going to be 3 open bracket 1 plus b is equals to -6. Therefore, making b equals to what? Is equals to -9. Then you're going to have a plus b, right, plus c is equals to what? Is equals to -1. Substitute a and b is going to be 1 minus 9 plus c is equals to -1. Therefore, making c equals to 7, right? Therefore, making Tn equals to what? Equals to Tn is going to be equals to n squared minus 9n plus 7. So that's going to be your Tn. Then the last question, it says, let me just take it down like this. So the last question says the first difference between two consecutive terms of the sequence E is 96. Calculate the value of the two terms. So they say the first difference, remember, the first difference, right? The first difference between two consecutive, very important, the first difference between two consecutive terms is 96, right? So they tell you the fact that this is the first difference, and they tell you the fact that there's two consecutive terms. So what do we need to use? We need to use the first difference to actually solve. This 96 is from this first difference. That's what I mean. So we're going to use the first difference, and the first difference is what? Is an arithmetic. So your Tn there is what? Is a, right, plus n minus 1 multiplied by d, right? And what do we have? We know the fact that the sequencing for the first difference is what? Is -6. I'm not going to write the first part. I'm just going to go by the first difference. So it's going to be like this. Then this is 13. And your difference here is 2. Right? So your difference here is 2. So here, what do we have? We are given 96, which is going to be Tn. So it's going to be 96. Right? And it's equals to a is going to be what? Is -6 plus n minus 1 multiplied by 2. How do we know whether to use the first difference or whether to use the quadratic? It does state which value they give us. Here they did state the fact that it's the first difference. And if they gave us the value of the quadratic, it's going to state the fact that it's the quadratic, right? So let's solve this. So we're going to take the 6 to the other side, which is we're going to have it to be 102, right, is equals to n minus 1, right, then 2. Divide both sides by 2. You're going to have 51, right, is equals to n minus 1. Then take the 1 to the other side. Therefore, n is going to be equals to what? To 52, right? So they said the fact that we need what? We need the 2 consecutive, so meaning it needs to be 2 terms. So it's going to be this one plus the next one, which is 53. So n is going to be also equals to 53. But they say calculate the values of the 2 terms. So we need to calculate the value of T52 and T53, right? So this is 53. So substitute wherever you see n, you're going to substitute 52 for the first one. So it's going to be what? Our Tn there is going to be, which is this one, is going to be 52 squared, right? This is 52 squared minus 9, 52, right? Plus 7, which is going to give me here, it's going to be this value, 2,253. Then for 53, we're going to substitute 53 by n. So it's going to be 53 squared minus 9. Then it's going to be 53 plus 7. It's going to give me plus 7. This is 7. It's going to give you what? It's going to give you 2,339. So now we're going to move to the geometric series and geometric sequencing and series notes. Then after that, you know the drill that we're going to do the questions. So let's go to the notes. So the first thing that you need to understand in geometric is that you need to know the fact that it deals with what? With a common ratio. So here we're going to be dealing with the common or constant ratio, right? Meaning what it means is the fact that the ratio is the same throughout when you find a difference. And the formula of finding the R, right, is going to be R is equals to Tn, right, divided by Tn minus 1, which is the same as when we start, the sequence is the same as saying T2, right, divided by T1. So this is going to be the same as Tn divided by n minus 1. When we take n as being 2, then it's going to be T2. Then at the bottom is going to be 2 minus 1, which is going to be T1. So that's what you need to know. Then to find the general form, right? Finding the general form. Finding the general form, right, of, let me just close this. Finding the general form is going to be Tn. Remember the general form, which is going to be the general formula, which is going to be Tn is equals to A, right? Then it's going to be R to the power n minus 1. Where A is the first term, so A, right, is the first term, which is the same. The A is the same here, and it's the same in the arithmetic and the quadratic. So A is the first term, right, which is T1. The bracket is the same as T1, right? Then R is the constant ratio. So R is going to be the constant ratio. So another extra information here that you need to know is that Tn, right? Another point is that Tn, right, creates, not create with the G, creates, right, creates a exponential curve, which is in simple terms is an exponential graph. So if you had to sketch Tn of the geometric, is going to give you what? An exponential graph. So Tn creates what? An exponential graph. Exponential graph. Alright, so that's what I wanted to say. Then now this is for sequencing, right? Now we're going to dealing with series. So under series you remember is the fact that is the adding of what? It's the adding of the sequencing terms, right? So under series, let me just write here and say series, because of here it has different situations. So under series, right? Which is, you can see in the question, they're going to say the fact that to see a series is that it's going to be additions, or you're going to see this symbol, which is sigma. If it has this 2, we're dealing with series. If it doesn't have this 2, we're dealing with sequencing, right? Just wanted to refresh you guys with that. Then under what you call this series, right, which is the sum of, like finding the sum of, let me just put a heading here saying the sum of geometric terms, right? Sum of geometrics. Remember when we started this video, we had the sum of arithmetic, and now we have another one, which is what? The sum of geometric. The only one that doesn't have the sum of is the quadratic. Because of the quadratic, the sum of it is in line with the what? Is in line with the arithmetic. I hope I'm making sense. So here it has 3 formulas, and those 3 formulas is for 3 situations, right? So first I'm going to deal with the 2 formulas for the 2 situations, then I'm going to deal with the last one for another situation. So for the first one is that if we have 4, let me say 4r, when r, right, is less than 1. What does it mean? When they say r is less than 1, in your head, just remember the fact that r is a fraction. If you get any number, like when you're finding the, what you call this, finding the difference, like when you're finding r in the situation, like in the sequencing, when they give you a sequencing, and you find that r is less than 1, meaning it's a fraction, or when I say a fraction, it's like 0 point something. Anything that's less than 1, then this formula for the sum of is going to be like that. It's going to be, it's going to say Sn is equals to a, right, open bracket, 1 minus r to the power n divided by 1 minus r. So this is a situation when r is less than 1. Anything that's less than 1, you're going to use this formula. Then you have a situation for r, right, is greater than 1. Meaning it's greater than 1, not greater than 2. Is greater than 1. Meaning r can be 2, 3, 2,5, 2,6. Anything that's greater than 1. Remember, everything that's greater than 1, then the formula is going to change. It's going to be like this. It's going to say Sn is equals to a, open bracket, it's going to be r to the power n minus 1, right, divided by what? Divided by r minus 1. So remember, your formula is determined by whether r is less than 1. It's determined the fact that when r, right, is less than 1, or when r is greater than 1, then you know which formula to use. Then with that said, we have sum of infinity, right? And sum of infinity is only for geometric. Arithmetic does not have sum of infinity. Only geometric has sum of infinity. So we have something that's called sum of infinity. So here, something to be sum of infinity, it needs to basically satisfy this first condition. Then after first satisfying this first condition, then you can find the sum of infinity. So to find the sum of infinity, first the series needs to be convergent, right? So the series needs to be convergent. the geometric series, very important, the geometric series, and need to be convergent. And how do we test for convergence? I'm going to show you. Convergent, right? So how do we test for convergent? To test for convergent, your R, right, needs to be between -1 and 1. If you get your R and it's between -1 and 1, then your series is convergent. Then you can find what? Then you can find your sum to infinity. And the sign for sum to infinity is S infinity is equals to, the formula is this, it's going to be A divided by 1 minus R. So this is the equation for sum of infinity. But to use this, you need to first find the fact that your R satisfies this condition where I put a tick. Then if it satisfies this condition where I put the tick, that means that the series is the series is convergent. Therefore you can find the sum of infinity. You can understand it more when we do questions. So that is the notes for geometric the sequence and series. So now let's move on to the questions, which is the past paper. So this is 2021, right? The November paper, right? So we are gonna start with this. So it says question 2. So it says, given that the geometric series x plus 90 plus 81 is equals to given that the geometric series is x plus 90 plus 81, then the first question they said, calculate x. So we need to find a, right? So first what we need to do, write your series on the side here so we can solve it properly. 90 plus 81, right, plus ... Then we need to find the difference. Not the difference, we need to find the common ratio. So remember the fact that it's T2 minus T1. Same applies when we were finding the difference in the arithmetic. Is always T2 minus T1. Here is T2, right, which is going to be 90 divided by what? Divided by T1, which is x. Remember, because of its geometric, we divide, we do not subtract. Then we know the fact that here is going to be T3 divided by T2. See, so it's going to be T3, which is 81 divided by 90, right? So remember what? Remember the fact that we have a common ratio. If we have a common ratio, meaning this one and this one are equals to each other. So to find x for 2.1, you can just try 2.1 here. It really doesn't matter. You're going to say 90, right, divided by x is going to be equals to what? To 81 divided by 90. Reason why I'm equating them is that they have a common ratio. Common ratio means the fact that the ratio here is the same with the ratio here. That's what I mean. So what we're going to do is we're going to cross multiply to solve for x, right? And when we cross multiply here, it's going to be what? 8,100, right? When you multiply 90 multiplied by 90, it's 8,100. Is equals to what? 81x, right? Then divide both sides by 81. So therefore you're going to find that your x is equals to what? Is equals to 100. So x here, which is going to be T1, is equals to 100. So now let's move on to the next question. Let me just move then the question down, right? It says, show that the sum of the n terms is Sn is equals to that. So sum of S terms, first we need to determine whether our R is it less than 1 or is it greater than 1. So now we need to find R so that we can know which formula to find Sn. So 2.2, right? We need to find Sn, so we need to determine R. R is equals to what? Remember from the top, let's go up. Is equals to, I'm going to take the one, this one, right, which is 81 divided by 90. If I do that, I'm going to say 81, right, divided by 90, which is I'm gonna get my r to be what? To be equals to 9 over 10, which is 9 over 10 when I put it into decimal is 0.9. 0.9 is definitely less than what? Less than 1. So I'm going to use the formula where it's for less than 1. So the formula for less than 1 is Sn, right? Is equals to what? Is equals to a, open bracket, 1 minus r to the power n, right? Divided by 1 minus r. So substitute your a, substitute your r. Our a is our x. Remember, the first term is going to be a. So our a is our x. So we're going to substitute Sn, right? Because of they said they want till the first n terms. So n is going to be still n. Then we're going to substitute at a. We're going to substitute 100 because of that's our a. Then we're going to say 1 minus. Then our fraction, not our fraction, our ratio is 9 over 10. So it's going to be 9 over 10. I'm going to put it in bracket to the power n, right? Divided by what? By 1 minus 9 over 10, right? So when if you take your calculator and say 100, right? Divided by 1 over 10, 1, then you're going to say 9 over 10, you're going to get 1,000 here. So this whole denominator, you're going to just divide it with this one, then you're going to get 1,000. So Sn is going to be equals to 1,000, right? Then open bracket is going to be 1 minus 9 over 10 to the power n, which is exactly like this, but you can change the 9 over 10 into a decimal. So it's the same saying Sn is equals to 1,000, right? Then you're going to say 1 minus 0.9, right, to the power n. Then you have exactly this Sn. So you got your 2 marks. So now moving to the last question for 2021. Then 2.3, it says hence or otherwise calculate the sum of infinity. Remember, to calculate the sum of infinity, first we need to determine the fact that it's actually convergent. Then after determining that it's convergent, then we can find the sum of infinity. We know for 2.3, right, we know that r is equals to what? To 0.9. Is r, therefore r is going to be between -1 and 1, because of 0.9 is between 1, -1 and 1, meaning the fact that the series is convergent, right? Is convergent. So since it's convergent, what can we do? We can find the sum of infinity. So the sum of infinity is equals to what? Is equals to a divided by 1 minus r, right? So when we say 1 minus r, we know the fact that a is 100, so it's going to be 100 divided by 1 minus 0.9. So that's going to give you what? That's going to give you 1,000. So a sum to infinity is equals to 1,000. I hope I didn't confuse everyone. And that's basically it for 2021. So now moving to 2020, it says question 3, it says prove that the sum to infinity, they give you the sigma sign, right? It started at k is equals to 1, then they give you the what? They give you the Tn, which is this, right? It's convergent series, show all calculations. So to find that, what we need to do is we need to write down this whole thing, right, into its components, right? To find r, then we can prove the fact that through r we can prove the fact that is the series convergent or not. So we know the fact that we have sigma, right? Then it's infinity, then k is equals to 1, then it's 4, then it's going to be 3, and it's going to be 2 minus k, right? So to find T1, T2, T3, this is what we're going to use, right? So we're going to first substitute T1 because it starts at k is equals to 1. So we're going to substitute at k. We're going to find T1, right? Which is going to be equals to what? Which is going to be equals to 4 multiplied by 3, 2 minus 1, which is going to give you what? Which is going to give you 12, right? Then find T2, substitute 2 at k. So it's going to be same thing, 4 multiplied by 3. Then it's going to be 2 minus 2, which is going to give you what? Which is going to give you 4, right? Then find T3. So find T3, which is going to be 4 multiplied by 3 to the power 2 minus 3, which is going to give me what? Which is going to give me 4 over 3, right? So remember to find R is what? Is Tn divided by n minus 2. So it's the same as saying T2, right? Divided by T1, which is going to give me what? T2 is what? Is 4. Then T1 is 12. Which is when I simplify this, I'm going to get what? I'm going to get 1 over 3. Just to check the fact that is R truly 1 over 3, I'm going to take T3 divided by T2, right? So I'm going to find another R, which is T3, right? Divided by T2, which is what? It's going to be 4 over 3. T2, which is going to be 4 over 3, right? This is the same as division, right? So I can say divided by T2, which is divided by 4, which is you're going to get your answer. When you punch this to the calculator, you're going to get 1 over 3. So we see the fact that R is 1 over 3, which is 1 over 3 is between, remember to prove convergent, right? For 3.1. To prove for convergent, first R, we know the fact that R is going to be equals to 1 over 3. And to prove convergent, R needs to be between what? Needs to be between 1, negative 1, and 1. And in our case, R is between 1 over 3 is 1 over 3 is between negative 1 and 1. So therefore, the series, right, is convergent. Is convergent. So that's how you prove convergence. Just make sure the fact that your R is between negative 1 and 1. So that's how you would do it. And I've showed calculations by finding R. Then now let's move to 3.2. Let me just go down to have space. It says if, right? They say if sum of infinity when k is equals to p, then 4.3 they give you Tn is equals to 2 over 9, meaning the sum of infinity. Basically they say if they give you the fact that the sum of infinity is equals to 2 divided by 9, right? And k, when you say k is equals to p, meaning it starts at k is equals to p, right? And when something starts at k is to p equals to p, remember the fact that the first number here, that k equals to p, is basically T1, which is equals to a. Remember that whatever number that is going to be T1, and that's going to be your a, right? So they tell us the fact that determine the value of p. So what are we determining? We're determining a, right? So let's substitute, right? So we know the fact that the sum of infinity using the formula is equals to what? Is equals to a divided by 1 over r, right? We already calculated. If you see this and this is exactly the same thing, the Tn's are exactly the same thing. So we already know the fact that r is equals to what? To 1 over 3. So what do we need? We need a, right? So to find a, we need to substitute here by the formula. We need to substitute what? We need to substitute k is equals to p. So we need to find for Tn, remember, right? We need to find Tp. And our Tp, as I said, Tp is equals to T1 in our case, because that's where it starts, and is equals to a. I hope I'm making sense. So now we're going to have to find Tp. I hope I haven't confused anyone, right? So we're going to find Tp. So we're going to substitute p here. So it's going to be what? It's going to be 4, right? multiplied by 3 to the power 2 minus p. That's our TP. So we know the fact that this is going to be equals to what? It's going to be equals to a, because that's our first term. So we're going to substitute this here for a. So we're going to say sum of infinity is equals to 4, right? Multiplied by 3 to the power 2 minus p, right? Divided by 1 minus 1 over 3, right? But we are not done yet, right? We already know the fact that the sum of infinity, they gave us here that this whole thing is equals to 2 over 9. So we know the fact that s infinity is equals to 2 over 9 is equals to exactly the same thing, but I'm gonna simplify the denominator, right? So it's gonna be 4 multiplied by 3 to the power 2 minus p, right? Divided by what? Divided by 2 over 3. Right? So what I'm going to do is I'm going to multiply both sides by 2 over 3. So I'm going to say 2 over 9, right? Multiplied by 2 over 3, right? Is equals to 4 multiplied by 3 to the power 2 minus p, right? Divided by 2 over 3, then multiplied by 2 over 3, right? So the 2 over 3 here are going to cancel out. Then here you're going to have what? When you say 2 over 9 divided by 9, 2 over 9 multiplied by 2 over 3, you are going to get 4 over 27, right? So here you're going to get 4 over 27 is equals to, it's equals to 4 multiplied by 3 to the power 2 minus p. Then divide both sides by what? By 4, so that you can have the 3 with the p alone, right? This side. So divide both sides, you're going to get 1 over 27 is equals to what? Is equals to 3 to the power 2 2 minus p, right? So make this 27. This is using exponential laws basically to find our p. Take this 27 upwards so that we can basically find the factors for that, so they can match us to being 3, right? So it's going to be 27, right, to the power negative 1. It's equals to 3 to the power 2 minus p, right? So now let's find the factors of 27. When you find the factors of 27, you're going to get the fact that, put it into a bracket, you're going to find the fact that 3 to the power 3 gives you 27. Then this is going to be negative 1, because of this is going to affect the entire thing. That's why I'm putting inside the bracket. It's equals to 3 to the power 2 minus p, right? Then multiply 3 and negative 1, which is you're going to get as 3 to the power negative 3 is equals to 3 to the power 2 minus p, right? Then now we are solving for what? We are solving for p. Since the bases are the same, we can drop them. So we're going to have negative 3 here is equals to 2 minus p, right? Then take the 2 to the other side, which is going to be negative 2. So you're going to have negative 5 is equals to negative p. Therefore, p is going to be equals to 5. So p here is going to be equals to 5. So that is the end of 2020. So now let's move to 2019 2.2. It says given a geometric series, right? Then that they give you the series. They say the fact that the 3 terms till infinity is equals to k. Then the first question says 2.2.1 says determine the value of k if the series has 21 terms. So what do we need? First we need to determine r. Then we need to know if r is less than 1, we know which formula that we need to use. If it's greater than 1, then we know. Then we're gonna find s to 21, right? Then that's basically how we answer the first question. So first, let me write down the sequence. So it's 5 over 8, right? Plus 5 over 16, right? Plus 5 over 32, plus it goes, and that's equals to k, right? and that's equals to k. So what we need to do now is that we need to find r. So to find r, remember, it's the fact that it's going to be t2 divided by t1. So it's going to be 5 divided by 16, right? Divided by what? Divided by the first term, which is going to be 5 over 8, right? Which is t2 divided by t1, which is, that's going to give you what? That's going to give you 1 over 2, right? Then now taking t3 divided by t2, I'm going to say 5, right? Divided by 32, just to check that our r is correct, right? That's going to be divided by what? Divided by 5 divided by 16, which is going to give me what? Which is going to give me 1 over 2. So therefore, we know the fact that r is going to be equals to 1 over 2, right? So that's our r. So to find, now we know the fact that we have r as 1 over 2, we can find s of 21. So now, since r is less than 1, we're going to use this formula for less than 1. Substitute your a and r. So we know the fact that n is still 21 terms, so it's going to be s21, right, is equals to a is this first term, which is 5 over 8, right? Then open bracket is going to be 1 minus 1 over 2 to the power 21, right? Then close bracket is going to be what? 1 minus 1 over 2. Punch that into the calculator. You're going to get your S21 to be what? To be 1,25, which is S21 is the same as K is equals to 125. So now 2.2.2, it says determine the largest value of n for which Tn is greater than 5 divided by 8,192. So here, what is the one that's unknown that we know definitely we can find n with is Tn. We already know how to find Tn, so let's find Tn, then substitute, right? So here we need to find Tn. So to find Tn, we know the fact that, so we need to first find Tn. So Tn, right, this is for 2.2.2. So we know the fact that Tn is going to be equals to AR to the power n minus 1. So we need a and r. So a is the first term and r is 1 over 2. Remember, we already calculated r, so we know that r is equals to 1 over 2. So let's substitute Tn. So Tn is going to be equals to, the first term is 5 over 8, right? Then r is 1 over 2 to the power n minus 1, right? Then after knowing the fact that that's our Tn, we see the fact that the question says Tn is greater than 8,192. So we're going to say Tn, right, is greater than that number, right? Then substitute Tn, which is we have as this. So it's going to be 5 over 8, right? Multiplied by what? Multiplied by 1 over 2, right, to the power n minus 1 is greater than 5 divided by 8,192, right? Then now what I'm going to do is I want the one that has the n alone, so I'm going to divide both sides by what? By 5 over 8. So I'm going to have 1 over 2, right, to the power n minus 1, right? It's greater than, remember, it's greater than, divide both sides, so it's going to be 5 divided by 8,192, right, divided by what? Divided by 5 over 8. Punch this side into the calculator. Then when you punch that side to the calculator, you're going to have, this side's going to remain the same, which is 1 over 2, right, to the power n minus 1 is greater than Then this side, when you punch it to the calculator, you're going to get 1 divided by what? By 1024, right? So after having that, it's 1024. I'm going to take the 2 up so that the base can be 2, and this can be in exponential form. So it's the same as saying the fact that 2 to the power negative 1, right, to the power n minus 1 is greater than. I'm going to take this number at the top 2. So it's the same as going to be 1024, right, to the power negative 1, right? Then now distribute the negative. So this is the same as this. Remember exponential laws. If the exponential here, we're going to multiply. So I'm going to say negative 1 multiplied by n, and say negative 1 multiplied by negative 1. So I'm going to have 2 to the power negative n plus 4 this side. It's going to be what? It's going to be greater than. Then this one I'm going to change into an exponential, which is when I change it to an exponential is the same as 2 to the power 10, right? 2 to the power 10 to the power negative 1. Then I'm going to distribute the negative here. So here I'm going to have it as the same, plus 1, right? It's going to be greater than 2 to the power negative 10. So I'm going to drop the 2's because they are the same. So when I drop it, I'm going to have negative n plus 1 is greater than negative 10. Take the 1 to the other side, I'm going to have negative n is greater than negative 11. I want to get rid of the negative, so I'm going to divide both sides by negative 1. Let me just do it in the next step because it affects the inequality sign. So I'm going to divide both sides by negative 1. So if I say negative 1 divided by 1, then equality, because if I'm dividing by a negative, is going to change and look the other direction. So it's going to be negative 11 divided by negative 1, which your answer now is going to be n is less than what? Is less than 11, right? So the question, let's go back to the question. It says determine the largest values of n terms. Since we know the fact that n, right, is less than 11, it's 11, not 10, is less than 11, right? The largest value is going to be, n is equals to 10. So n equals to 10 is going to be your final answer here. So now let's move on to 2018. It says a geometric series has a constant ratio of 1/2, and it says the sum of infinity is equals to 6. So what are we given? Let's write down the given information. We are given first a constant ratio. So we know the fact that for 3.1, because we're going to need it. So the first question says calculate the first term. So 3.1, we know the fact that what are we given? The information we're given that r is equals to 1/2, right? And also we given that the sum of infinity, right, is equals to what? Is equals to 6. So we know the fact that as infinity is equals to 6, right? So what do we know? We know the fact that we given the sum of infinity and we given r, and we need to look for the first term, which is the first term is a. So in basic terms, what is a? So we can use the formula for sum of infinity, which is s, right, is equals to a divided by what? Divided by 1/r. We have sum of infinity and we have r. So the only unknown term here is a. So let's substitute the sum of infinity and the half. So we have 6 here is equals to what? Is equals to a, which is the one that we're looking for, divided by 1 minus 1/2, right? So take this, this side is going to be 6 is equals to a, right, divided by positive 1/2. Multiply multiply both sides by 1/2, so it's going to be the same as 6 multiplied by 1/2. Here it's going to cancel out, which is going to be equals to a, making our a, right, equals to what? Equals to 3. So here we know the fact that a is going to be equals to 3. So the second question says calculate the 8th term of the series. So we know the fact that we're looking for T8, right? So to find T8, we're going to use the general formula, which is Tn is equals to A, right, multiplied by R n minus 1. So here we already have A and we have already R, right? So we're going to substitute. We know A, we already calculated it to being 3, so it's going to be 3 multiplied by 1 over 2, which is our R to the power. Our n is 8 because we're looking for the 8th term, right? So it's going to be 8 minus 1, right? So punch that into the calculator. You're going to find that T8 is equals to 3 divided by what? By 128, right? So now moving to 3.3, it says given the summation, so it gives you the summation is equals to what? To 5,12125. Calculate the value of n. So what do we see? We see the fact that it ends at n and it starts at k is equals to 1, right? Then again is that they gave us that the sum of this whole term is equals to 5,12. So what we need to do is we need to use the sum formula to find our n. So to find the sum formula, right, is that we need to find what? We need to find our a and we need to find our r. So to find our a and r, we're going to use this as being our tn, but in this case, because it's in k, it's going to be our tk. So we know the fact that tk is equals to what? To 3 open bracket 2, then it's going to be 1 minus k, right? So substitute your T1, right? To find T1, we know the fact that we're finding A. So T1 is going to be equals to 3, open bracket. Remember the fact that the first term, whatever T this is, that's going to be your A, right? So in our case, is K is equals to 1. So our T1 is going to be our A. Then it's going to be 2. Then close bracket is going to be 1 minus 1, which is going to give us 3. Right? So now we need to find R. To find R, remember, we need what? We need T2 divided by T1, right? So now we need to find T2 because we already have T1. So T2 is equals to what? Is equals to 3 open bracket 2. It's going to be 2 to the power 1 minus 2, right? Which is going to give you what? Which is going to give you 3 over 2. Right? So now we're going to find our R. So our R is going to be what? It's going to be the same as T2, right? Divided by T1, which is going to give us T2, right? It's going to be 3 over 2 divided by T1, which is 3. When you punch that into the calculator, you're going to get what? You're going to get your R as being 1 over 2. So we know the fact that R is 1 over 2 and our A is what? Our A is 3, right? Which is exactly the original question, but I just did it the long way so that if you are not given the original, you know how to solve it, right? So after finding those two components, we know the fact that we can use what? Since R is less than 1, we can use this formula. So we can say Sn, right, is equals to A open bracket 1 minus R to the power n divided by what? Divided by 1 over 1 minus R, right? So we already know the fact that Sn, they already gave us as 5,8125, right? Then our A, we know the fact that is 3, right? Then open bracket 1 minus R to the power what? To the power n. Remember the fact that R we are also given, it's a half. We just calculated it. It's a half to the power n, then divided by what? By 1 minus 1 over 2, right? So I'm gonna simplify the denominator. So you're gonna have what? This side you're gonna have 5,8125 is equals to what? Is equals to 3. Then it's gonna be 1 minus 1 over 2, right? To the power n. Then here's gonna be what? 1 over 2, right? Then you're gonna take this 1 over 2, multiply it with this number. So it's going to be, when you do that, you're going to get 93, right? When you say 5,8125 multiply by a half, you're going to get 93 divided by 32, right? And that's going to give you this side. The half is no longer there, so it's going to be 3 open bracket 1 minus 1 over 2 to the power n, right? Then now divide both sides by 3. So when you divide both sides by 3, this side you're going to get what? You're going to get 31, right, divided by 32. So this is 31 divided by 32. So this side you're no longer going to have a 3, so you're going to have 1 minus 1 over 2, right, to the power n. So this brackets, you can cancel them, right? So now you can have 1. So you can take this one to the other side. So it's going to be 31 divided by 32 minus 1, which is you're going to get minus 1 over 32, right, is equals to what? To negative 1 over 2 to the power n, right? So since both sides are negative, I can just write it into being a positive. So you're going to have 1 over 32 is equals to 1 over 2 to the power n, right? Take this 32 to the top, so you're going to have 32 to the power negative 1 is equals to, take the 2 to the top, right? You're going to have what? You're going to have 2 to the power negative 1 to the power n, right? Change this 32. When you change this 32, it's the same as saying 2 to the power 5, right? Negative 1. And this side, multiply negative 1 to n, so it's going to be the same as 2 to the power negative n. Multiply 5 to negative 1, so it's the same as 2 to the power negative 5 is equals to what? Is equals to 2 to the power negative n. Drop the bases, which is the 2, so you're going to have negative 5 is equals to negative n. Remember, this is negative. So therefore, n is equals to 5. This is 5. So our n here is going to be equals to what? It's going to be equals to 5. So here, the value is going to be that n is equals to 5. So let's do 3.4. It says if sigma, right, it ends at 20 here, as you can see, then it starts at k is equals to 1. Then they give you the fact that 3 open bracket 2 close bracket 1 minus k is equals to p. So if this whole thing, right, is equals to p, so we know the fact that this form is equals to p, then they tell you the fact that write down the sigma where it ends at 20 and start as k is equals to 1, but then they give us like a different formula here in terms of p. So what we need to do is we need to take the one they want us to write in terms into, like the one that they gave us, which is this one that they want us to write in terms of p, and make sure the fact that we have this formula within this one. So let's take that. Then it's k is equals to 1 here. Then we have 24, right? Then open bracket, we have 2 to the power negative k, right? So I'm going to write the one that is p here in pink. So we have the fact that it's sigma, then it's 20, right? Then it's k is equals to 1. Then we have 3 open bracket 2, right, to the power 1 minus k. So what do we see? We see the fact that I'm going to write the things that are common to both. What do we see? We see the fact that we have 2 here, we have 2, right? So both of them we have 2, so there's nothing that we should change there. We see the fact that it's sigma, it ends at 20 and start at k minus 1, and the one that they want us to change and write into p is the same thing. So we have that, right? Then what do we see? We see the fact that we have negative k here, and we also have negative k here. So what do we need? We need the 3 from the pink one to be here, so they can be what? It can complete this whole thing, so they can be p, and also we need 1, right? So to do that, we have to change this 24 so that we can get a term 3 in front of it, and we can get the negative 1. So let's do that. So we're going to take this one, right? Just write it again. It's going to be equals to then it's going to be k is equals to 1, right? Then change this 24. If you find the factors of 24, right, it's going to be what? It's going to be 3 multiplied by what? Multiplied by 2 to the power 3, right? Then we're gonna rewrite what? We're gonna rewrite this 2 the way it is, which is gonna be 2 to the power negative k, right? So the only thing that we did here is change this 24 into being this, right? I'm just highlighting so that you can know that the 24 is the one that changed, right? So now what do we see? Now we have our 3, which is perfect, but now what we left with 1. What do we know? We know the fact that we can split this 2 to the power 3 into being what? 2, into being 2 to the power 2 plus 1. So let's do that. So it's going to be 20 here. Same thing. Then it's going to be k is equals to 1. Then we're going to have 3, right? Multiplied by this one. The 2 to the power 3 can be changed as being 2 to the power 2 plus 1, right? 2 to the power 3 and 2 to the power 2 plus 1 is the same thing. So then here it's going to be 2. Then this is going to be negative k, right? So what do we know? We know the fact that since 2 now is the same base, I can split this into being 2 to the power 2. First, let me do that. We can split 2 to the power 2 multiplied by 2 to the power 1, right? So let's do that. So it's going to be sigma. It's going to be 20 here. Then this one is going to be k is equals to 1. Then it's going to be 3. Then this can be split into 2 to the power 2, right? Multiply 2 to the power 1. Right? Then this is going to be multiplied by what? By the one inside the bracket, which is 2 to the power negative k, right? So still we are not done. What do we know? We know the fact that if I add this 2, I'm going to have what? I'm going to have 1 minus k. If I add this 2 together, the exponential, right? Because of it's the same base and they're multiplying, I can add the exponential. It's going to be 1 plus negative k, which is going to be the same as 1 minus k. So let me do that. So it's going to be sigma here. Then it's going to be 20. Then it's going to be k is equals to 1, right? Then here it's going to be 3. Then here it's going to be 2 to the power 2. Then add this to the one that I highlighted, right? So when I add the 2, it's going to be the same as what? As being 2 to the power 1 minus k. Right? Because we added the exponential there. So what do we see? We see the fact that we have 1 minus k as the exponential. We have 3. So let me group them so that I can write that in terms of p. So when I group them, it's going to be group them so I can look exactly by the one that's equal to p. So it's going to be the same as 20 here. Then it's going to be k is equals to 1. So when I say 3, this is equals. Then multiply by 2 to the power 1 minus k, right? Then multiply by this 2 to the power 2. Do you see the fact that this whole portion, this one, let me just highlight it so that you can see it. Do you see the fact that this whole portion is equals to what? Is equals to p. So that whole portion is going to be p now because they told us that this whole thing is equals to p. So you're going to say this is going to be p multiplied by 2 to the power 2. 2 to the power 2 is equals to 4. So this is the same as saying this whole answer is equals to 4p. So now moving to 2017, it says a convergent geometric series consisting of only positive term has the first term a. So very important, we know the fact that it's positive terms, right? And it has the first term, which is a, which is we know the fact that t1 is a, and a constant ratio of r, and the nth term, which is tn, that we know. Then they tell us extra information that the sum of infinity when n is equals to 3, tn, right, is equals to 1 over 4. Then they say the first question, if t1 plus t2 is equals to 2, write down a and in terms of r. So what do we know? We know the fact that t1, right, is equals to a. t1 is always a. Then what do we know? Do we know the fact that to find t2, we need to multiply t1 by what? By r. So it's going to be a multiplied by r to find t2, right? So now I'm going to write t1 plus t2 which is equals to 2. Then I'm going to substitute T1 and T2, right? So we know the fact that T1 is what is A and T2 is AR, right? Which is this, which is AR is equals to 2. So now we need to write A in terms of R. So I'm going to take A as a common factor. So it's going to be A. Then it's going to be 1 plus R is equals to 2, right? Then divide both sides by 1 over 3. So it's going to be 1 plus 3, sorry. Then 1 plus 3. So the 1 plus 3 here are going to cancel out. Therefore, A is going to be equals to 2 divided by 1 plus 3. Then we're done with the first question. So now 3.2, it says calculate the value of A and R. So what do we know? We know the fact that they gave us the sum of infinity when n is equals to 3, right, of t n is equals to 1 over 4. That's what we given. Also, we given that t1 plus t2 is equals to 2. So to find A, what do we need? We need t1 because of t1 gives us A, and the sum of infinity needs to have the first term. So here the sum of infinity only starts at 3, but we already given that t1 plus t2 is equals to what? Is equals to 2, right? So we know the fact that t1 plus t2, right, plus sum of infinity, right, when n is equals to 3 of Tn is equals to what? To the sum of infinity, the formula. Because of, remember that the formula has A, so our sigma can't start at 3, but it needs to start at 1, at T1, because of T1 is A. I hope I'm making sense, right? So now we know the fact that T1 plus T2 is equals to what? Is equals to 2. And we also know that the sum of infinity when n is equals to 3 of Tn is equals to what? Is equals to 1 over 4. So this side is going to be 1 over 4 is equals to the sum of infinity, right? So 2, right, plus 1 over 4 is going to give you what? It's going to give you 9 divided by 4, right, is equals to the sum of infinity. Now I'm going to substitute the sum of infinity, right, so that we can find A and R. So we know the fact that this is going to be 9 over 4. Then the formula here is A divided by 1 minus R, right? So what is the good thing? The good thing is that we already solved A in terms of R. So here I'm going to substitute A, right? In where, what you call this, I'm going to substitute A, which is going to be, I'm going to substitute it with this. So to do that, I'm going to rearrange this. We know the fact that A divided by 1 minus R is the same as saying what? As saying A multiplied by 1 minus R. This and this are exactly the same. So I'm going to substitute A here in this form, right? So it's going to be 9 divided by 4 is equals to what? It's going to be equals to, our A is going to be 2 divided by 1 plus R inside a bracket. Then we're going to have 1 minus R, right? So let's go up so we can solve for R here. So I'm gonna multiply numerator by numerator and denominator by denominator. So here it's gonna be 9 divided by 4 is equals to 2 multiplied by 1 is going to be 2. Then here at the bottom is a difference of 2 squares. So which is I'm gonna have as being what? As being 1 minus R squared, right? So having that, now I'm gonna cross multiply, right? So when I cross multiply, I'm going to have 9 multiplied by this one. So it's going to be 9, open bracket, 1 minus R squared is equals to 4 multiplied by 2, which is going to give me 8, right? So after doing that, what I'm going to do is I'm going to distribute what? I'm going to distribute the 9. So I'm going to have 9 minus 9R squared is equals to 8, right? Take the 9 to the other side. I'm going to have 9R squared is equals to what? It's going to be equals to, it's going to be equals to negative 1, right? So this side is negative 9R squared. Divide both sides by negative 9. So R squared is going to be equals to, so when I divide both sides by negative 9, I'm going to have this side. The side's going to be R squared. And the side's going to be 1 divided by 9, right? And then I'm going to have to find the square root of R. So here's going to be r is equals to plus or minus, right, the square root of this, which is going to be 1 over 3. So it's going to be 1 over 3. But remember, in the question they said only positive terms. Remember, they said the geometric series consisting of only positive terms, so therefore our r needs to be positive. So r is going to be equals to 1 over 3. Then now we have our r, so now let's substitute for a. So remember, we solved that a is equals to what? Is equals to 2 divided by 1 minus r. Substitute my r is going to be 2 divided by 1 minus 1 over 3 plus, it's not 1, it's plus, right? So it's a was 2 divided by 1 plus r. Then when we substitute our r, it's going to be equals to what? 3 divided by 2. So that's going to be our r, and that's going to be our a. So now let's move to 2016. It says rectangles of a width of 1 centimeter. So let me highlight the important information. So they said the rectangles, right, of a width of 1 centimeter are drawn from the edge of the sheet of paper, which is 30 centimeters long, such as there is 1 centimeter gap in between one rectangle to the next, right? Then they say the length of the first rectangle, so we know that the length of the first rectangle is 21, and the length of each successor rectangle, right, the one that follows basically, is 85%. So what do we know? We know the fact that see the length of the first rectangle. So we know the fact that T1, which is a, is equals to what? Is equals to 21 centimeters. They told us the length of the first, which is triangle, which is the first triangle, is going to be the first one, which is T1, which is a, which is 21 centimeters. Then they say the one that follows is going to be always 85, which is the 85 is the ratio, right? So the ratio, the constant ratio there is going to be 85%, which is 85% is the same as 0.85, right? So that's what we know. So looking at the picture, this is what we have. See, the length of the first rectangle is 21. Then the the width of it is 21, right? Then the length is 1 centimeter. Then it's an open space of 1 centimeter. Then it's the next one, which is 85% less. Do you get it? That's how it goes. I hope I'm making sense. So every time it's going to be the 21, it's going to be 85 of the previous one, 85 of the previous one. So that's how it goes, right? So it says calculate the length of the 10th rectangle. So what do they want? They want T10. So 3.2.1, they want T10. So what do we know? We know the fact that to find T10, we need Tn is equals to a multiplied by r, which is n minus 1, right? So we know the fact that our a is what? Is 21. Then multiply by what? By r, which is 0.85, because it's 85%. Then to the power 10, because that's the one that we want, minus 1. Then we find the fact that T10 is equals to 4.86. So we're done with the first one. So now let's move to the second question. It says calculate the percentage of the paper that is covered in gray. So the one that's covered in gray is what? Is the rectangles, right? So we need to first find the sum of the rectangles. Then after finding the sum of rectangles, then we need to find the area of the paper. Then after finding the area of the paper, we can find the percentage. So let me just write notes so that when the next time when you do this question alone, you have notes to actually follow on how I did this question. So 3.2.2. So first we need to find the sum, right, of the gray color, right, which is the sum of the rectangles, right, gray colored, right? Then I'm gonna write, since I'm gonna explain it after writing, since, let me write this, since the length is 30 centimeters, right, and each gray block, which is the rectangle, remember, is 1 centimeter, right? Is 1 centimeter. Therefore, the amount of gray blocks that can fit this paper, that can fit, is 30 divided by 2, 30 centimeters divided by 2, which is going to be 15, right? So in total there's going to be 15 blocks. Remember the fact that the 1 centimeter, then there's an open space that's not gray, which is another centimeter. That's why I took the total divided by 2, because of this. In total is going to be 30 blocks, and there's going to be 30. It's going to be, I took the 30 and divided by 2 because of it's going to be 30 of the gray ones, and it's going to, not 30, it's going to be 15 of the gray ones, then it's going to be 15 of the white ones. That's what I mean. So to find now, knowing the fact that there is 15 gray blocks, I can find the sum of 15 blocks, the total of it, right? Because we need the percentage of the gray blocks, right, in this complete paper. I hope I'm making sense. So I'm gonna find Sn, right? Then I know the formula is going to be this one. The reason why I'm using this one is because of r is less than 1, right? So it's going to be 1 minus r. So we're going to find S of 15, because that's the total gray blocks. So it's going to be equals to, the first term is the first rectangle, so which is 21 centimeter. Then it's going to be 1 minus 0.85, which is r to the power n, right? To the power 15, not n, right? Then this is going to be divided by 1 minus 0.85. Then we're going to find that the sum of 15, right, is going to be equals to what? It's going to be equals to 127.77. So this is the total of the gray blocks. I hope I haven't lost anyone, right? Then now we need to find the percentage. So to find the percentage, we first need the area of the page. So now it's finding the percentage, right? So we need to find the area, which is the area is going to be the total, right? So we're going to find the area, which is going to be the total. So we need the area of the entire page. So the area of the page, right, is equals to what? To the length times breadth, right? So it's going to be 21, right? Let me just show you, because it's going to be 21 multiplied by 30. So let's do that. 21 multiplied by 30, which is, it's going to give you what? 630, right? So that's the total area of the page, where it includes the white and the gray bars, right? So what we need to do is, now we need to find the percentage, right? So what we're going to do is, we're going to take the total of the gray blocks divided by what? Divided by the page, right? The area of the page. So finding the percentage, of the page of the paper covered in gray ink, right? It's going to be equals to what? To this one that you just found, which is 127.77, right? Divided by the total, which is the total area, which is 330. Then that's going to give you what? That's going to give you 0.2028. Then we want it to be percentage, so take this answer and multiply it by 100. So your percentage is going to be 20.28%. Then you're done with this question. So now moving to 2015, it says given the following geometric series, right? So what we're going to do is we're going to write down the series here. So it's 10, it's 5, it's 2, 5, right? It's 1, 2, 5, right? Then it continues. So before doing anything and answering the question, we're going to find the common ratio. So to find the common ratio, it's going to be what? It's the second term divided by the first term, right? So it's going to be 10. It's going to be 10. Let me write it here. It's going to be 5, sorry, divided by 10, which is going to give you what? 1 over 2, right? So it's going to give you 1 over 2. Then for the other one is 2, 5, right? Divided by 5. So it's the third term divided by the second term, which is going to give you a half. When you say 2, 5 divided by 5, it's going to give you what? A half. Then the last one is going to be what? It's going to be 1,25 divided by 2, 5, which is going to give you 1 over 2. So our common ratio here is what? It's a half. So we know the fact that R is a half, right? So now let's go to the question. The first one, they say, calculate the value of the fifth term, right? T5 of the sequence. So we know the fact that this is T1, this is T2, T3, T4, and they're looking for T5. So you can use the formula, which is that's what I'm going to use. Or you can multiply the fourth term by the common ratio to get the fifth term. I'm going to do it with both ways. So 2.1, you can say T5 is equals to what? The fourth term, right? So T4 multiplied by the ratio, which is the same as 1,25 multiplied by 1 over 2, which is you're going to get that your T5 is going to be equals to 5 over 8, right? Or you can do it by doing what? By using the formula. So you know that the formula Tn, right, is equals to A multiplied by Rn minus 1. So we're looking for T5. So it's going to be T5 is equals to A is the first term, which is 10, multiplied by what? By R, which is 1 over 2. Then to the power what? N is 5 minus 1, which is you're going to get 5 over 8, right? So you can do it with either step. You're still going to get your answer as being the same thing, right? Then now moving to 2.2, it says determine the n term Tn in terms of n, right? So we know the fact that the Tn formula is going to be Tn is equals to A multiplied by R to the power n minus 1. We're looking for Tn, so n remains the same. So now we're going to substitute A and R. So we know the fact that's going to be Tn is equals to, our A is 10, open bracket, 1 over 2, to the power what? To the power n minus 1. So that's your answer for 2.2. Then 2.3. It says explain why the infinite sequence 10 plus 5 plus 2, 5 plus 1, 25, which is the same thing. They changed the sequence into a series. Sorry, the infinite series, they changed it into series as convergent. To test for convergence, remember the fact that you need to find R, and R needs to be between -1 and what you call this, a -1 and 1, right? So we know the fact that our R in our case is equals to 1 over 2, and 1 over 2 is between -1, right? Is between this. We know the fact that what you call this 1 over 2, right, is between this. Therefore, since it's between -1 and 1, therefore the series is convergent. So you get a mark for this, stating this, the fact that it's between -1 or 2. Or even if you write it like this, like you say R is 1 over 2, and you say the fact that it's this, or you can write it the fact that you substitute the R, you get a mark, and you get a mark to say the fact that the series is convergent. It converges, right? So you are done with that question. So now let's go up. Then the last question says determine S infinity minus Sn in a form of a b to the power n. So they want us to write it in terms of exponential, right? where Sn is the sum of n terms and of the of the sequence. So what do we know? They want us to find 2.4. They want us to find S infinity, right, minus Sn. And n doesn't have the last term. We need to write it in terms of n. That's what we know. So first, let's find S infinity. So S infinity is equals to a divided by 1 minus r. Substitute your a and r. Our a is 10. Let's go up. See, our a is 10. So it's going to be 10 divided by 1 minus 1 over 2. Where when you're done substituting there, you're going to get your S infinity being equals to what? Being equals to 20, right? So now we know the fact that S infinity is 20. Now let's find Sn. So Sn is going to be equals to what? It's going to be equals to a open bracket 1 minus r to the power n divided by 1 minus r. The reason why we use this formula is because of r is less than 1. So that's why I use this formula. Substitute your a and r. So Sn, right, is going to be equals to what? Our a is 10, open bracket 1 minus 1 over 2, right, to the power n. Then divided by what? Divided by 1 minus, right, 1 minus 1 over 2. Do you see the fact that this 10 divided by 1 over 2 is the same as this one? So we know the fact that this is going to be equals to 20. When you say 10 divided by 1 minus 1 over 2, it's going to give you 20. Then what's going to be remaining in the bracket remains the same. So it's going to be 1 minus 1 over 2 divided by n, right? So now we have S infinity and Sn. So we know the fact that now S infinity minus Sn is going to be equals to, let's substitute for S infinity, substitute 20 minus open bracket, for this one is going to be 20, right, open bracket 1 minus, then it's going to be 1 minus 1 over 2 to the power n, close your bracket, right? So now let's distribute the 20 before we distribute the negative sign. So when we distribute the 20, it's going to be 20. This is going to remain the same, minus. Then here it's going to be 20, right, minus 20, 1 over 2 to the power n, right? Then close your bracket, distribute the negative now. So when you distribute the negative, it's going to be equals to what? It's going to be equals to 20 minus 20 plus 20, open a bracket, 1 over 2 to the power n. Do you see the fact that the 20 and plus 20 are going to cancel each other? It's going to be equals to 0. So you're going to be left with 20, open bracket, 1 over 2 to the power n. Remember at the top they said they want us, let me go up so I can show you. They said they want your answer to be in terms of what? A multiplied by b to the power n. See here at the bottom, our answer is in terms of a multiplied by b, a which is 20, b is 1 over 2, and n. So your final answer is 20, open bracket, 1 over 2 to the power n. And we're done with 2015. So now let's move to 2014, which is the last question for this video. I hope you guys are as excited and you guys understood so far. But it says the first 3 terms of a geometric sequence are, it's 16. Let's write it down. So it's 16, it's 4, and it's 1. Before we do anything, let's just find the ratio. So to find the ratio, remember it's going to be what? It's going to be the second term divided by the first term. So it's going to be 16 divided by 4. You can say 16 divided by 4 like this in terms of a fraction, or it can be 16 divided by, it can be 4, sorry, it's the second term, imagine, it's the second term divided by the first term, so it's going to be 4 divided by 16, or you can say 4 divided like the sign by 16. It really doesn't matter. You're going to get 1 over 4 here. Then for this one, it's going to be the third term divided by the second term, which is 1 divided by 4, which is going to get 1 over 4. So now we know the fact that our ratio is what? Our constant ratio is 1 over 4, right? So now let's move on to the question. They say calculate the value of the 12th term, leave your answer in the simplest exponential form, right? So we're looking for 3,2.1. We're looking for T12, right? So we know the fact that Tn, I'm just going to write it in another color, just pink. Yeah, pink. So we know the fact that Tn, right, is equals to, let me just write it here because you're going to need it either way. So we know the fact that Tn is equals to A multiplied by r to the power n minus 1, right? We're looking for T12, so it's going to be T12. Then our A is the first term, which is 16, right? Open bracket. Our constant ratio, which is r, is 1/4. To the power n is 12 minus 1, right? So let's simplify the 12, the 12 minus 1. Remember the fact that leave your answer to the simplest exponential form. So we need to simplify this. We can't leave it the way it is, right? So now let's change the 16 into being a factor of 4. So it's going to be equals to what? 16 is the same as 2 to the power 4, right? Then now let's take this 4 outwards. So it's going to be 4 to the power negative 1, right? 12 minus 1 is going to give you 11, right? You're still not done. So this is going to be 2 to the power 4. Then the 4 can be changed into being what? Let me do a square bracket because there's just a lot going on here. So it's going to be square bracket, right? It's going to be 2 to the power 2, right? To the power negative 1. But this whole thing is to the power 11. Then now distribute, multiply 2 and negative 1. So you're going to have 2 to the power 4. Then it's going to be 2 to the power negative 2, right? To the power 11. Multiply a negative 2 and 11. So you're going to have 2 to the power 4, right? Then that's going to be multiplied by what? 2 to the power negative 22, right? So since they are both the same base, you can what? We can add the exponential. So it's going to be 2 to the power 4 plus negative 22. Punch this exponential into the calculator. You're going to get 2 to the power negative 18. Then changing it to a positive exponential, it's going to be 1 divided by 2 to the power 18. So now moving to 3.2.2, it says calculate the sum of the first 10 terms. So we're looking for Sn. So we have 3.2.2. We're looking for Sn. Then I'm going to use this formula, 1 minus r to the power n divided by 1 minus r. Remember why we're using this formula is because of r is what? Is less than 1. So that's why I'm using this one. Substitute everything. We're looking for s to the 10 terms. So is S10 is equals to, the first term is 16. Open your bracket. It's going to be what? 1 minus 1/4 to the power 10, right? Close your bracket. Then it's going to be 1 minus 1/4. Punch that into the calculator. S10, right? The sum of 10 terms is 21,33. Then you are done with 3.2.2. Then now let's move on to 3.3.3, right? It says determine the value. Then they give you is 1 plus a half inside a bracket, and everything is multiplying, right? So let's look at it and notice a pattern. The first one, every bracket has a 1, right? Then the first one, the way it starts with 1/2. It starts at 2, 3. Like here, what I'm talking about, let me just show you. See, every bracket has a 1. Then the next term is 1/2. But let's look at the denominator of the each bracket, right? The next term. It's 2, it's 3, it's 4, it's 5, right? And they say the fact that the factors is still what? It's still 98. So we know the fact that our thing is going to look like this. Let's rewrite it. It's going to be 1 plus 1/2, right? Then it's going to be 1 plus 1/3, right? Then it's going to be 1 plus 1/4. Then it's going to be 1 plus 1/5, right? Then it's still how many terms? Still 98 terms, The reason why I'm saying look at the pattern, the fact that here it's 2, 3, 4, 5. So it's always, since this is the first term, right? What the denominator value is the term after the term. Since this one is the first term, it's a half. This one is the second term, but it's 1/3. This one is the third term, but it's 1/4. So here the last term is going to be what? Since it's 98, it needs to be 1 over the next term, which is going to be 99. So it's going to be the same as 1 plus 1/99. I hope that made sense. Because of here the first term, here it's not 1/1, but it's 1/2. It's always the next term. The denominator value is always the next term. So if we take that pattern, the fact that the second term is 1/3 and the fourth term is 1/4, 1 plus obviously, and the fourth term is 1/5. Here the 98 factor is going to be 1 plus the next term. It can't be 98, because for, if we say it's 98, it's going to be for what? For 97, right? So we know the fact that here is going to be the next term, which is going to be 1/99. I hope that made sense, right? With that knowledge, right, now let's simplify each bracket. So when you simplify each bracket, it's going to be what? It's going to be 3 divided by 2. Then here is going to be 4 divided by what? It's going to be 4 divided by 3. Then this one is going to be 5 divided by 4. Then here is going to be what? It's going to be 6 divided by 5. Then up to, when you simplify this one, you're going to get, it's going to be 100 divided by 99, right? So now look at this. Since everything is multiplying with each other, we can cancel the numerator to the denominator. See, we see the fact that this and this are the same, so everything cancel out, right? So everything cancel out. If here we create a term that's before, which is going to be 99, right? Divided by what? Divided by 98. What do we see? We see the fact that the 99 are going to cancel because this is the last term, and this one is going to cancel with whatever term that's in front of it. So every factor is going to cancel. So what are you going to be left with? You're going to be left with 1/2, right, multiplied by 100 divided by 1, basically. Then that, therefore, if you punch this into the calculator, you're going to get your answer as being 50. So that's how you do this question. So we are done with our number patterns. So yeah, so the next video, which I think is gonna come out for the next 3 weeks, if like you watching it now, right, is that it's gonna come after the next 3 weeks, is going to be functions. I hope this helped you a lot and it has clarified certain questions. So I'll see you on the next video.